It's not wireless for a reason. And I have to fix the mute button. So we need to go into OBS. Or we need to go into Stream Deck and fix my mute button. That's an important thing to have. Stream Deck. Mute me. Title, mute me. Source. Huh. You are too. Toggle mute. Does it actually work? Hold on. That works. Okay, cool. So now I got that going on. Why is my compressor falling so... Look at how long that persists. I don't know if maybe I did a setting on that, but I seem to be in the right range, so that's okay. So I guess that does the audio stuff. We're good with that. So now we go to the overlays. That's the important one. That's going to be tough to wrangle because I've actually got to get rid of all of the overlays and all of the scenes and then replace them with my overlay source. The overlay source doesn't have audio on it, so I'm going to go blank for a minute. Yeah, so like when it activates there, it'll be visible in all of the scenes that I've put it in. I didn't put it in that scene. I haven't put it there yet. Okay, so I've got overlay in this scene, so technically I could get rid of the other one. Let me put it into all of the other scenes so that overlay is there, and then we'll fix the Stream Deck buttons. This is part of the miscellaneous, and I know stream start soon is on the screen, but it's, I don't know, whatever. Oh, and we got to pop out YouTube. One sec, pop out YouTube. YouTube, hit refresh. Go to this with my freaky thumbnail, and then we're going to pop out the chat. What, another ad? What is it? Okay, I got to find a better... I guess my YouTube stuff is probably broken, so it's full of ads. Maybe the Skylon is just the full album without ads in between everything. Might be. Yeah, this one doesn't have ads. Okay, that was some other uploader that put ads all over OTT's album so that they could profit off of his music. Of course, I'm playing it as the background music for Twitch so that I can profit off of his music. Let's not pay too much attention to that. Okay, so this one has the overlay scene on it. So all of the stuff that's activated in that scene. The only problem is when I want to play with my overlays, when I want to like rearrange them and move them around, they are stuck in that scene. And I need to go to that scene in order to play around and rearrange them, I think. Unless there's some weird way that I can... But let's add the overlay scene to everybody. So plus, let's add scene. I would show you this being done, but I can't do it while showing a different scene. I guess maybe that's what broadcast mode allows you to do. Okay, overlay scene is on top of everything, and it's got to be the first scene of every single one. It also means that unique positions for items in different scenes, that's not really going to be a thing. Everything's just going to be a straight up overlay. And maybe I can make an additional one or two in order to put unique stuff in unique places for different scenes, but then you've got to unview one and view the other. That's why folders were a more interesting way to do it. You have your folder of your overlays, and then each scene can have its unique positioning. I don't know how to get around that with OBS. Unless I do something in Node-RED where when I switch to a scene, it'll turn on and off the appropriate overlays. That could be a thing. And I could even transition them. This is essentially what Lorraine board or whatever, and that other one, the one that Flatulent wants me to use. I'm going to cough. That's what they do. They do all these unique things with your overlays. What am I adding? I'm adding overlay. It's all the way down here. Overlay scene. That. Microscope. Plus. Overlay scene is overlay scene. Okay. Spring arm. Oh, yeah, there's not much difference between the two. Plus. Scene, overlay scene, okay, PC programming, plus the scene, This'll only take a minute. I didn't do this. I don't know why. That very top. The game zoom. The game zoom does not get the overlay scene. I don't think it'll get the overlay scene because these don't really work in here. Yeah, some of them do, but a lot of them don't. Move BG out of there. Well, yeah, I don't know. What's up, lines and squares? I'll just remove overlays from this as a whole. Yeah, this one gets the audio, but it doesn't get any of the overlays. Oh, that was for the AutoCAD add thing. That overlay is big. Bad hair day. I'm good. I'm fixing some stuff in OBS right now. I don't know why this scene exists. Why would I want my face cam while I've got my hands down here? I think I'm going to get rid of this one. This whole scene is dead. Goodbye, scene. It's like you never know what your layout is going to need to be, but that one is kind of a unique use case, this one, so I guess I will leave it. So add the scene, overlay scene. You're supposed to have all these sources in their own scene, not in their own folder, even though that doesn't make much sense. It's just OBS is stable this way. It's just OBS, for some reason, is stable this way. The right-hand PC, I don't think I need this one. I think I'm going to get rid of this one. This one's that screen all the way over there, and you guys can just see that. Yeah, this one isn't useful. This one is all of my webcams. So I can just do a quick status check on everything. So for that one, I'm going to add, well, this one doesn't have overlays anyway, but, oh, yes, it does. Okay, so I'm going to add a scene. It's called overlay a scene. Overlay scene. Okay. That one, and then we can get rid of overlays. It doesn't make much sense, but apparently this is the way to do it, and it makes it a little bit simpler for using like the automation stuff, the OBS WebSocket tool. I didn't have too many issues with it. It's just I wanted unique positions per scene. Okay, I got to go back and delete all of the overlay stuff. I guess that one doesn't have overlays, does it? Okay, so there's chat, audio source, Streamlabs, chat overlay. That's the game zoom. That one does not have any overlays. Overlay and audio, and then, wait, whoa. What doing? Oh, those are unique overlays, I see. That, yes. Up here, a couple unique ones. Get rid of the folder called overlays. I have an order of like 10,000 ramen noodles coming today. Point? Oh, that's a weird one. Get rid of some of the garbage in these scenes. There's a lot. Okay, that's good. And then this one, remove the overlay. Okay, so I might have nuked a couple overlays in there by doing that, but I can always make them again. We can always rebuild them. Okay, how's everybody doing? Now I need to fix Stream Deck. So like, start soon doesn't do anything. So let's go into the button here. Oops, this is action 1. Source visibility, start soon. Scene, overlay scene. Source, start soon. Done. This one, title. Overlays. Start soon. There we go. Now, if I hit the button, okay, you know, there we go. Start soon, and then every scene. Why are there two? Oh, because the overlay folder is still here. Goodbye. There we go. One single stream starts soon. Ah! Why are there... why do some of these have multiples? Oh my god, they all do. I've been through this. I deleted them. I guess I didn't get very far, huh? Yeah, there was still a couple hiding all the way up at the top. Okay, so now all of them have the same position, which I'm not a huge fan of, but that's just the way things need to work. So cool. All right, so now we need to do all of these. In here. Oh god, there's so many. Start soon off. I got a job interview in France. Oh, where you live, okay. I'm wondering if I'll get screwed by Trump's tariff. The company I applied to does a lot of business with the US. There's a lot of that going around and it sucks. I am vehemently against everything that is going on right now. It is a bunch of bullshit, and it's just because in the 80s he got somehow that idea worm got into his fucking dumbass head. Hey, what's up, Lawn Dog? It's like everything they do just makes everybody around him suffer, and that's all it is. That's all it's about. It seems that's as nihilistic as it gets. So I wish things were different, but apparently that guy got it into his head. So this one starts soon. Oh my god, it's hard to find these in these lists. Soon, there we go. This one. Overlay scene. Start soon again. Here we go. Fixed. On to the next one. BRB. On and off. Bourbon. I could use Bourbon right now. Overlay scene, BRB2. This one, overlay scene, BRB2. There we go. That one's fixed. Oh, but it needs a title. Wait, it has one. Why is it blank? What the fuck? Oh. I don't even have BRB on right now. Why is that? Weird. That was toggled in the wrong spot. BGM slightly too loud? I mean, that was a big crescendo. It should mostly be in the background. I'll turn it down just a tiny little bit and see if that's worked for you. Well, the turmoil, I got survival. Bottle Atlantis. That's good. The survival bottle. I hate having to get that, but it gives me a little bit of lead time and magically to some degree. It was all the price I wanted. Not totally the price, but affordable for now. All right. Well, yeah, that's good resolution. Glad you didn't have to go into emergency mode. Everybody seems to be against it. Yeah, everyone's against them. Like, everyone. Economics, Ronald Reagan, like, everyone is against these fucking things. And they're persistent in doing it, probably just because they want to blow the place up or something. I don't know. Start soon off. No. Okay, start soon. Overlay scene, start soon. Soon off. Overlay scene, start soon. Okay, done with that one. BRB, we got walkies. Oh, without a title, it just assigns its own thing, doesn't it? Wait, but these don't need to be multi-action then. Source visibility. Yeah, let's make these into source visibility. copy these. We don't need these to be multi-action. Start soon. Where is it? Why did that one stay AB and this one changed into a little YouTube thing? Huh. Overlay scene. And it's, oh, because one is text and the other is an actual little like video. I see. Start soon. This one's BRB2. And so now, even though it's a little less exciting, if I hit the button, oh, it's off screen. Damn it. I have to coax it back on screen. But it highlights the whole button instead of changing the image. Okay, I'm up to date with it. So this would be overlay, walkies, overlay, tech issue, overlay, blood glucose. I think rack view is a legitimate, yeah, rack view is its own thing. That's camera settings. Freak, overlay, freak. I don't know if the freak file is where it should be. Pee pee poo poo, overlay, pee pee poo poo. How you doing? Overlay. How you doing? Which one was that? Which one was that? What did I call it? Pumpkin. There it is. How you doing? Kappa. Does this mute work? Yeah, okay. Mute just naturally works. Overlay scene. I'll have to fix the positioning of these still. I don't know how to do it in OBS where you can like pull them all into view. Quiet Pumpkin is going to keep its title, overlay scene, and then it's pumpkin dance. There we go. Think is a multi-action. Overlay scene. I think I renamed it to thinking. Yes, I did. Good. Thinking, and then source visibility. This is going to be in, not in audio sources. It's going to be in the overlay, I guess. And that's think sound. And this has to be turning them off. Even though it could be a multi-action and just do number 1 because it does source visibility. How do you get rid of number 2? Guess I can't. Oh no, not that. Oh, okay. Well, gotta fix them anyway. Overlay scene and thinking. And then overlay scene, think sound. So toggle them on and off. And finally, the louder pumpkin, which gets, see, this, the thing is the think stuff is copyrighted music too. I don't know if I can set that source to only go on the one channel. I kind of want it on both just because it's comedy. I might get in trouble with YouTube one day for those. Did we fix pumpkin? We did not. Overlay, Pumpkin Man, where is that? That one. Overlay, pumpkin sound. Same with this. Deactivate, pumpkin. Oh, overlay scene, pumpkin. And this one, overlay scene, pumpkin sound. What this allows me to do is more easily set up Node-RED to turn things on and off. The only thing is, like, when I comedically activate one of my sources, I don't think I'm able to do that anymore. One of my overlay sources, without, I have to like go into the scene, but I can't, I have to click into the scene and then everything goes. It's not good. I don't know how to alleviate that. I don't know how I can edit that scene without. Yeah, so that's the problem. There's one big problem, is that in that overlay scene, I can't turn on and off. If I right click, it immediately goes to that scene. This is just how OBS works. So if I wanted to comedically activate an overlay, I have to just do it in the scene. So like stuff like this on that multi-overlay thing, it doesn't work. So I don't know if I'll have to set something up for that. But that also means that, like, I guess those have to be contained within. It's a whole reorganization of how everything works. But now I might be able to use Node-RED in order to activate stuff. So where else do we have overlays in Stream Deck rather? Where else are there overlays? I think I got this one. Yeah, we got that one. Although I could turn it into the other type. That one opens up a bunch of web pages. That's nothing to do with anything else. Okay, so that one's fine. Scenes, this is just activating scenes, so that should be fine too. Yeah, that's fine. I think I've fixed it. I've got a very simplistic setup here. But maybe one day I can actually get in here and make it for the Stream Deck XL, and then I'll have all this space for all my different stuff on there. And then the overlay scene can have every single overlay, so all I have to do is use the Stream Deck in order to activate any of the number of overlays that I have in there, whether they be little one-off comedy ones or not. Now, the microphone mutes when I go into this scene, so I can't edit it right now. So some of this stuff is off camera. Like if I hit a BRB, where is the BRB? There's a little evidence of it over there. Let me fix that one real quick because we might need that one today. All right, so that does that one. So now when I do BRB, BRB comes up. Huzzah! I make that one a little bigger because it's more of an issue when there's BRB. But I don't have any of the other ones. Stupid no audio scene. It's like this void where all of my overlays exist. So I'll have to fix that one off air. So now I can go into Node-RED. What is monitoring chat? If it contains start soon, is there start soon? Scene name. Actually, can I call it overlays now? I'm just going to call it overlay scene. There's a space in there. I wonder if I should use an underscore. Overlay scene. Source name. Scene name. Overlay scene. Source name. This one is called... Uh-oh, I need to get the name of it. Start soon. 2 capitals. Cheap bands by talking about cheap viewers at blah blah blah.com. Thanks for the first time chat, blah 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 blah, whatever the fuck you're... Privy dishwasher Oscaquad. AI generated name. Jesus Christ. We're at like the sweet spot for viewers, aren't we? It's like 30. 10? 10 people watching my stream. What the heck? Misc projects probably soldering the HV circuit mostly is my title. Yeah, when you get to a certain amount of viewers, you get these spam bots, and I guess 10 to 12, 10 to 20, 20 to 30, you know, usually that'll get you a couple of those. But it's I don't know. We're just starting out here. It's the start soon dialogue. I've been streaming for like 30 minutes almost. I thought I'd get more viewers than this. I guess I don't know. I'm hemorrhaging viewers. Request get scene item ID done. Let's try deploying that and seeing if we can get that in the debug. And I'm going to clear the pad and deploy, confirm the deploy, and then we'll hit it with a toggle. Wait, the survey is running a more recent set of flows. Oh, merge. There we go. I did a little OBS work to get some addresses right. Can viewers be bots too? The thing is, when we ban a bot, they still count as a viewer if they're in the chat. Twitch is just broken like that. So bots can be viewers. Can viewers be bots? If you're a physical robot sitting behind the keyboard, then yes. But we ban robots here, and then they still count as viewers, and they don't bother us. Scene item ID 58. That worked. It worked. We got it to work. So starts soon as 58. I don't have a piece of paper to write that down. So now, is it start soon? Request. Get scene item list, scene item source, create, remove, transform, get scene item enabled. Overlay scene. Wait, start soon dot spring arm. What? I'll say I was against all this immoral madness when the robot revolution happens. The bots finally get us. Scene name, overlay scene. Comma. Scene. Scene item ID, right? Scene item ID, lowercase d. Scene item ID, colon, quote, starts, scene item ID, 58. There's probably some missing stuff there, but. Invalid JSON property. Field of scene item ID must be a number. Oh, it's just a number, I see. I'm still getting invalid JSON property from where? Oh, from setback. All right, we'll figure that one out later, Node-RED. But first, toggle. No scene items were found at the scene overlay scene with the ID 58. But it just, scene item ID 58. That's what it told me. Did it change? Oh, wait. No, that's part of the sentence, right? The period? Colon 58. Scene item ID. What the heck? You just gave me a scene item ID. Okay, get scene item ID. Get scene item ID. Overlay scene. A scene item name. Transform, blend mode. Okay. Get scene item ID. Scene item name would be start soon. And then deploy. I need to turn this into like a script so that I can type something in, do multiple tests. Source name. Oh. It's a scene item, but it's a source. Source name, done. Deploy. Confirm. What up, Hairbothan? It changed to 11. Now it's source item ID 11. Maybe because I had all that weird stuff in there that it changed to 58. So if I'm going to just take this Dracula flow and turn it into my own thing. This one, and this one. Copy, paste, put it here. And this would be scene ID get. Done. So I need another toggle to test this other one. So overlay scene, source name, this is scene item ID. Scene item ID, and it's just 11. Done. I wonder if that's number 11 in the overlay scene. Hold on, it's going to go quiet for a second. It's not the 0th item. I counted. Sorry about the quiet. I don't have audio on that thing because I don't want to double the audio sources. I think it'd double the audio sources if the scene has audio in it. And I could maybe make I could make a flow for Node Red that would activate the audio source in that scene when I click into it. That's probably a good thing to do. I could probably make that so that I can go into my overlays and still talk. So we have is starting soon is going to be scene name overlay scene. Scene item ID is 11. And we're going to check to see what that says on the debug. This is just to get the scene item ID of the thing. And I guess I can turn this one into start sooner so that we can get that source ID. So now I'm going to deploy this. And we can get start sooner. You son of a bitch. What do you mean there's nothing in there? It's I just saw it. I just looked at it. Okay, all right. So let's try. Is it active? Source name. It needs a name and an ID. That's ridiculous. Why would it need both? They're conflicting. So it's source name. It said those were optional fields. At least in the thing we looked at. I guess whoever programmed this thing is evil. The source name. Oh, that's in quotes. Hold on. Source name, quote, colon, quote, start soon. This is like too much stuff to go through just to check to see if a source is active. This should be so much easier to do. You know, I should just give it either the scene item ID or the source item ID. Or the source name, rather. It's either of those, and then if it's in there, if it's not in there, give me the error message. But I've identified it by ID, so I need this extra thing. And I don't know if that changes if I move it somewhere. It's stupid. All right, so get scene item ID, done. deploy, confirm, clear, check. Oops, wrong one. That was get the scene item ID. Burp. Error, no scene items found in the specified scene with that name or offset. Oh, that's the one there, but this one, oh, this one gets the flow. So that means it succeeded. With all that information, it actually succeeded, and there is now a packet coming through here. So the next part is, we've already checked to see if the source is on because we get that flow. So then we turn on and off the thing, and then we have a delay, and then we turn off and on. Okay, so let's do this whole guy here. Take this, bring it down here. So then what is this guy doing? Multi-action. Ah! My eyes! What's up, Last Miles? How's it going? Yeah, so we're working on the flows, the Dracula flows that will control things in the shop. So I've Tasmotized this bulb, and I can send it commands through Node-RED. And so through the Node-RED and the OBS stuff and all this other stuff that I'm able to do, I'm able to actually toggle stuff on and off. So what I'm doing is payload start soon. Scene name is overlay scene on both of these. Overlay scene, overlay scene. Scene, and then we put a comma in there and a quote. We go scene item ID. Oh, it's lowercase d. Uppercase I, lowercase d. Scene item ID. It's unfortunately you need all of this information to make it work. Scene item ID is 11, just the number 11, comma. Scene. Is it scene or source? Hold on, let's So chat message contains start soon. So then we activate a request to see if the scene name, overlay scene, scene item ID is 11, source name is start soon. Source name start soon, comma. I hate how it has to have all of the information. Scene item enabled 0. And that is in message.payload.startSoon, which will go through the filter and then go to the batch request. Scene item enabled, payload.startSoon. Set the Steam item, start soon, and then start sooner is down there. How goes burn the subs? It hasn't been going, and it's kind of a soft spot on my head that everybody seems to love to poke. Oops, my folder's in the way. We're getting to it. I mean, I'm learning Node-RED. That's kind of what this is all about, is getting to know Node-RED. Getting to know Node-RED is a big deal. And so the work that I'm doing right now is towards getting stuff like functioning in Node-RED so that I can then bring that functionality into burn the subs. Where's this visible? No, it's gonna fall. Like up here. No, there's a belt right there. We put it here. There we go. That's not really visible. Oh well. Would it not be easier to install the clapper? No, this is very specific and very petty, actually. So we need to get that running again. 18 terabytes? Jesus. I heard tape drives are pretty cheap these days. They're not all that expensive. So CNAME overlay scene enabled. Let's copy that as if we got it right and put it in here. And I guess I can test that flow entirely, and it'll throw some errors, but if it turns off and on the start soon, then we'll have done it correctly. And actually, something off there, yeah, and then over here it turns it back on. So this, oop, no, no, no. 1. Oh, that's actually a nicer way to do it. Overlay scene, the ID is 11. Source name starts soon. Scene item enabled 1. Actually, wait, that should be a Boolean. So this should be just the number 1. Or can I do true? We'll try true and false. Oh, they're lowercase, aren't they? False and true. Yeah, see how there's an error on it? It needs to be T. Why did that view in a different way? There we go. Okay. There, see, it's highlighted. Yeah, okay, perfect. Tape drives are the best until they age, and then you have big troubles. Just try reading an IBM 6250 tape reel in 2025. OctoJ did a whole bunch of tape backups. I don't know where he got his stuff. One of my moderators, OctoJ, it was a whole saga. Hey, what's up, Mr. Copper? Yeah, he did these linear tape drives, and they're cool. They're like 8-track recorders. They hold an absolute buttload of information, but it took him forever because he did like full DVD scans and then backed everything up to tapes. But they last like 30 years. And apparently you get a ton of space for them. There's a reason for annual checkups on the backups. I would not be able to do that without automation. I just would not remember it. So what's going to happen is I'm going to throw a bunch of errors, right? Because all those other commands, the second commands in here, are not worked out yet because I didn't get an item ID from start sooner. Let me go look at the overlay. It's going to go quiet for just a second here. Okay, start sooner is full caps from the beginning. Let's just check to see so we can get that item ID. Yeah, I did a lowercase s at the beginning, and it hated it. So capital S, and let's just check our JSON. Scene name, overlay scene, source name, start sooner. This gives us the ID number, which is not required, but apparently it is required. In other versions of the OBS, whatever, the node plugin, I guess, the WebSockets plugin, it only needs ID or name, but apparently in this one, it needs both ID or name because we gave it the ID and it said it needed a name. Hold on, I'm gonna cough. Woo, okay. LTO is for the year 2000, so that doesn't help. Oh. LTO 7 can read LTO 6 and 5. I don't know anything about that. What do you know anything about tape backups? Still have 40-year-old tapes, tough to read them. Damn. This is as old as I am. Last Miles with a sub. 8 months, pretty sure I was banned for a year. Yeah, I don't think you were you read banned for a year? No. I don't think so. I don't think I ever banned you or anything. I think I killed your chat once for a joke. I did that to somebody. I forget who. It was just for a joke. Oh, banned by Twitch from everything. What did you do? What did you do? What did he do? Okay, let's get the scene item ID, and then we can punch it into this stuff. And then we get this. 12. One was 11, the other was 12. Great. Okay, so on and off, and so we take this one, and I'm going to copy this one, paste it, and it's JSON expression, and this one turns this one. Oh, great. With true. Truey. Start sooner. Item ID is 12. So scene name, overlay scene, scene item ID 12. Now, does this show up as JSON? Oh no, it's a, there we go, JSON. There we go, that's easier. Okay, done. And then done with that one. And now over here, we set it to be false. And this is a JSON, and it is false. There you go. Done with that. Done. And now I should be able to check the chat message to see if it says start soon. If it contains the word start soon and the start soon thing is enabled. Wait, not get scene item ID. Get scene item enabled. Get scene item enabled. Done. And then we need contains true. Move these guys down. Contains true. We haven't looked at what it looks like yet, but we'll just take some assumptions here as I'm learning how these things work. Okay, so I was a grouchy old man, need to learn better manners. Oh no, that's no bueno. You got to be extra super saccharine to everybody. Hello, chat. I'm the nicest person in the world. How's everybody doing? Ha 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 ha. Okay, so contain start soon is start soon on if it contains true, which I feel like there's a better node for that, but whatever. If it contains true, then we set two properties in the payload. So the payload starts soon and the payload starts sooner, and that should probably be capital S, capital S, capital S. Let me just make sure. This is not capital. Let's check the JSON. Capital S, overlay scene, 11, starts soon. Good, we're done. We're done. We double check. The other one starts soon, 12, overlay scene, true. The other one is false, right? Yes. Done, done. And so now these set them back. Capital S, overlay scene. Let's check that that's source name. I started them with capitals and I shouldn't have. Overlay scene 11, start soon, enable true. This one is false, false, capital S. Okay, done. Whew. Variables in programming. Da 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 da. Question for you, serious question. Was the decision to go partner on Twitch worth the hassle? I've been sitting on that for months. They're going to reject you the first time. There we go. They're going to reject you the first time that you apply for partner. That's just how it goes. You get rejected, and then a couple weeks later, you try again. And then if number is above value, that's it. And then you're partnered. What came of that decision? What did I grant? What was granted to me? I think a bunch of like more remote slots, some other stuff. Twitch actually sent me a whole package of partner goods. So I have this a fleece blanket, or no, it's what is that? It's a very soft blanket. I think it's fleece. Yeah, I have a fleece blanket that says Twitch partner on it repeatedly, and I turned that into a dog bed. So that was kind of cool. I got a bunch of socks, even though I don't wear Twitch socks. I got a something that we need to automate, and now that the Node-RED stuff is active, we can also mess with that. We can make a chat-controlled Connect 4 game that uses the Twitch partner Connect 4 game that they sent me. This is a while ago. I don't know if they're still doing that program. No t-shirts. They didn't send me a single t-shirt. They had a little pad charger that was the Twitch logo, pretty cheaply made. It was a bunch of just kitschy stuff, right? It was kind of cool to get, though. I got some pins that are Twitch themed. I didn't get any magnets, though. Magnets would have been a really good one for this stuff. But anyway, it was just a bunch of kitschy stuff for being partner. Also, if I go to cons, I can get into like a partner area, even though if you're barely a partner, you're in the same area as the people that have 10,000 subscribers. Cool, maybe I can network doing that sometime. and actually get more than 11 viewers. We're up to 16. My God. Today's a very slow Tuesday. I don't know what's going on. We have about the same number of, yeah, we're about getting there even. Yeah. Curious if it was worth it. I think so. I think a little bit of prestige is nice after streaming for so long. You get that partner logo next to your name, and so some streamers who aren't acclimated to the fact that you're just a total bum floating around the internet will read off your chats as if you're a very popular streamer. They go, oh, that's a partner in my chat. That might be worth a couple viewers. And I'm like, nope, I'm a scrub. But yeah, then they eventually learn that I'm in fact homeless in terms of partner prestige, and then they start ignoring me again. But I think I pissed off a whole group of streamers doing that. Well, you have a nice beard. I got that going for me. Yeah, I've got that going for me. Yeah, if you guys haven't checked out, let's do a shout out for Last Miles. I feel like even though we only have 15 people here, we'll just do a shout out to Last Miles. I hope I got that right. Yeah, I think I did. Gained a few viewers from it. I never did. T-shirts, when companies do send them, never the right size, blah, 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 blah. Whatever. But you can always cut up the T-shirt and make it into something. My beard is old and gray and getting longer and older. And yes, I am a mouthy, grouchy old fart. However, I do fun software sometimes. Yeah, I know of Last Miles. I have done my due diligence. Let's see if my Dracula flows work. Should that be an expression? No, I think it just contains the text true. Let's try it. So deploy, and then if I do nothing happens. Okay. I will quietly lurk. Hey, no problem. I don't mind chatting. I literally typed start soon. Raw event.message text. Oh, is it message text? Hold on. Chat, oh bother, down here. Raw event. Message type. Message. Raw event. Message text. Contains start soon. So if I take my very message, the one right before, it'll go down to raw event, message, text, literally start soon. This is exactly the thing, but I didn't get any feedback about it. Something's still messing up. So let's get our debug 3 on the output of his start soon. Let's get result end error. Clear that. Deploy that. Close. His start soon. True. Scene item enabled. Okay, so scene item enabled. Oh, it was looking in the wrong place. So message payload dot object, or is it just payload dot scene item enabled? I think payload dot object. No 2 dots in there, 1 dot. Am I good? Okay, done. Hold on, let me check how I'm. Dane starts in. No, it's just payload. Okay, so object isn't. No, that's not part of it. Okay, contains true, needs to do payload dot scene item enabled. Done. Okay. Get rid of the debugs because now we know what's going on. So deploy, close, toggle it. No, it's a big thing. Ah, damn it! Both of my things. Wrong data types in request. Types currently request type string, request data undefined. So my method of putting the data into the command are bad. setting it payload.startSoon is equal to the JSON. This is called Node-RED, and Node-RED has to do with Java flowing from end to end. And so as we flow through things, we're doing things like checking to see whether or not a scene is started. And if it is, if the scene is currently active, then it does stuff. It sends commands out using the various things. But each flow is like a little blob of functionality that you have to kind of cobble together in order to make something go from one end to the other. That's sort of what you do with Node-RED. So what I've done is I've set this thing up so that when Twitch logs in, when this logs into the Twitch event sub system and an event happens, it goes to all this stuff. It goes to all these different flows. And what these do is these check to see whether the payload.event type. So there's a Java flow that's being manipulated here. If the event type is channel chat message, then it passes it on to these three to check if the chat message contains start soon, if it contains the word aw, or if it contains the word idea. And I have different functionality for each of these. If it says aw, then it sets the message payload to be a timing, and it sends it to the punch box, which is not actually connected. It says it's connected, but it's not. Or if it contains idea, it'll change the message text to say yellow 80. It's like a command for the Tasmota light. And it sends it to this, and then it also starts a 2-second delay. And after the 2-second delay, I have an off command that then gets sent to the bulb. This filter just makes sure that each chat message is unique. No duplicates can be sent. So if multiple people are trying to trigger the robots at the same time, only one of those is going to go through. Sick automation, great job inventing. Thanks. It's a little bit more involved than a lot of like what a lot of streamers use, but it's Node-RED, so it's like infinitely configurable because it's more of a programming language than just a plugin that allows me to do stuff on Twitch. Like there are ways that you can do this much easier. There's a whole system that some dudes have programmed, and it's way more functional than what I have so far. But in the sense that I'm doing this on like the ground level, because Node-RED is a programming language for Java and like Raspberry Pi and stuff. It is not a Twitch automation thing. So I'm not waiting for features. I'm not limited by features. I can just do whatever I want with this. That's my justification. It's slim, but it's enough for me. Okay, so what's happening? So it's like we're breaking Java over here because we're sending what? It is set to this value. Payload.startSoon. Let's check. Ah, here it is. Capital S. Capital S. Done. That should fix it. Deploy. So now, if somebody says start soon, I can petulantly have that toggle up. Oh, it's perfect. It needs to be a little longer. And then later on, I can add like a transition or something like that. I wonder how the transitions work, because if I could have it, enable it, and then have it slide across the screen, that would be pretty awesome. I'm going to adjust the overlay though. Hold on. It's going to go quiet while I do this, just because of the way things are organized. There we go. So now, if I say, that wasn't too bad. We got that working. That was pretty cool. So now it puts it up for 4 seconds every time somebody says start soon in chat. I could make it even more petulant if I really wanted to, but I think it's good the way it is. So I'm going to get that out of there because that flow's done. And this is evil laugh.mp3. How's it going, lines and squares? I'm getting to everything. I mean, you know, like people have been kind of like mean about asking me about if burn the subs is done. And it's like, dude, I'm a human being. I work in real time. Sometimes I can't get everything done all the time. And it's nice to get a little bit of progress on even something petty like this is teaching me more Node-RED. So it's all moving towards an end goal. None of it is superfluous to this goal. There we go. Okay. You can give these a bit more room. Just keep it nice and organized. All right, so everybody's good and ready. Let's work on the punch box. We got some soldering to do. Even though I just finished this robot, but there's well, the number of viewers is growing. That's pretty good. It's doing well. Usually not an hour into the stream, I have typically more people, but the stream, well, my schedule hasn't been too bad. I did a Saturday stream. For some reason, Saturday streams like kick down the number of viewers. But I'm still gonna do them. I mean, I'm not gonna be completely like beholden to my number of viewers. I think that's a silly thing for a streamer to do. I just like to keep wary of it. I think I need to iron the collars on these shirts. They're kind of, it's kind of like collapsing. Anyway, yeah, let's get to business here. I just made a thing that petulantly does this. If I say start soon. Maybe it should be a little more than 4 seconds, huh? Maybe 5 seconds is a sweet spot. That didn't feel like it was petulant enough. Yeah, I think 5 seconds is probably the sweet spot. It doesn't get through the full animation. Less than 100 viewers and I just start drinking. Give up. Tomorrow's another day. Evil laugh from an old grouch. Look, there's the big streamers, I love watching them melt down when they don't have a lot of viewers. One of the things about like sort of my level of streaming and your level as well, I just don't want to single you out, is that we're just past the point of being completely comfortable streaming to 0 viewers. Because that's like when you start out on Twitch, having a schedule is the best thing you can do to get viewers. And there are people who like to watch like, you know, very few people with very few numbers. But it's like you have to be able to just talk to yourself and stream to nobody, which is a little bit of what I'm doing right now. I just keep myself occupied with my own voice. It's a very vain sort of thing to go through. But yeah, this petulantly making a giant stream start soon so that I don't have to address people asking me whether or not the stream has started soon. And now that I've moved my overlays into a single scene, I can control that much easier. Talk or mutter. Yeah, it's either one. We're gonna get into soldering now. Let's get into soldering. And yeah, like people should not be at all put off by the fact that like if you're the only person in chat, you make a giant block of wall of text. I don't care. I love that. If I don't have a lot of people talking and I've got one person interacting with me, that's fine. I'm totally cool with that. It's a little bit weird when you're that block wall of text. I've been it before with friends, but who cares? Like, right? Interaction is king. Now, if I go to setup and I remove the start soon and I do, what's up, Perzhinki? Some days I can say Perzhinki's name totally. Perzhinki's, I don't know how to pronounce it, to be honest. Have you heard about the Tiny Tape Out project? I don't think I have. Back when I streamed regularly, I considered it an awesome day if I had 8 to 10 watching. I remember those days. Start soon. Oops, there's a slash in there. Well, that should have still gotten it. So that works. The flow works. If I have start soon active and somebody says, why is stream starting? It gets enormous just to spite them. And later on, I can use transforms to kind of make it stretch it out and put it back. Better to have chat flowing than not flowing at all. But yeah, running into a case of maxing out the character limit is fun. I love, what I love is watching the larger streamers try to trigger people into talking more. So one streamer that I happen to know, will start talking these completely bullshit political takes, and then chat starts flowing and flowing and flowing. Or they'll not understand a concept in English that they understand in Swedish, and I know they understand in English, but they'll just not understand it. And everybody, correct him, he's saying something wrong. It's kind of amazing. All right, let's get start soon out of here. So what are we working on today? Well. Today I want to do miscellaneous projects, but like I said in the title, it's probably just going to be the high volt emote thrower. I haven't gotten a lot of progress on it, so I want to do just a little bit of soldering today. And it's always fun to solder because, you know, that gets you viewers and all that fun stuff. So I need to get this thing a little bit further along. This is one of these chat interactive projects that helps me learn OBS. Well, not really OBS, but the whole Node-RED thing that I'm working on. And that's what we were just working on. I just added a flow for start soon. But I've got all these different sort of chat flows. I've got rage flows. I've got sub or gift flows. I have channel point redemption flows, and I have channel shout out flows. I haven't done anything with channel shout out. I can't think of what to do with that yet. But soldering equals meditation plus sniffing poison. I love aerosolized lead. But anyway, so yeah, we've got a bunch of different flows here, and I'm starting to learn kind of how to manipulate them and get them running in Node-RED. It is quite a powerful piece of software. I can do just about anything that my stupid brain can come up with, as long as I can figure out how to translate it into flows. Because I've been doing microcontrollers for a long time, so everything looks like microcontrollers to me. How do I put this in a for loop? How do I do this and that and the other thing? Translating it into Java flows is like a little bit alien, but you kind of start to peel apart the veneer and figure out what's going on after just being exposed to it. It's kind of exposure therapy. We've made bulb 2, which is the one that's sitting right here, into the ideal light. So if somebody says idea in the chat, I petulantly light up the ideal light in the color of a light bulb, yellow. If other stuff happens, if somebody subs, this will turn on red. If somebody raids into the channel, it'll turn on purple. So that gives me just a little bit of an indicator of what's going on, because I don't do audio alerts. I hate audio alerts, and I've ridden them from this channel. You won't get that typical doo-doo, like casino noise from my channel. Those are designed to manipulate your brain, and on like a fundamental level, and I hate it. I think it's just immoral of these chat notification services to have the casino noises associated with you putting money into a machine. I hate that. But we're making something similar where if you put an awe emote into my chat, it will kick a solenoid, and one of these little 3D printed emotes that I was sent from a viewer will be kicked up into my face. So that will be funny. Eventually we can either put a percentile, like a percent chance about whether or not it'll actually kick an emote, or I could make it a channel point redeem. Either way, we can put it behind some kind of a virtual paywall if it gets more popular. But for now, it is literally just connected to putting an awe emote in chat. We are still working on the PCB for this, because we decided, since I bought this. I bought a 100 volt meter, DC 100 volt meter, and I have these 250 volt capacitors. They're actually, how many volts are these things? 1500 microfarads, 200 W watt volt. I think they're 200 volts. Anyway, these huge 200 volt capacitors, right? So I can store up a lot of amps in these things, and I can charge it with a Nixie tube power supply. Where is that? Nixie tube power supply that I can crank up to 100 volts. This is for like neon lamps. It puts very few milliamps out. And then I can control that with a 3 volt, it's a Wemos D1 Mini. Don't be fooled by the chips on top. It's basically an ESP with a little bit more oomph to it. I bought this a long time ago. It needs a job. So we're going to put this on this, and we got it kind of pseudo working, right, immediately. We got it working. It had no op amps. It was using a TIP 122 Darlington transistor. Darlington is when you set off a tiny transistor that sets off a big transistor. So it's a Darlington array. So we set off this Darlington, and it switches ground onto the 100 volt circuit, and then the solenoid gives us a nice heavy clunk, right? This just goes thunk, and it kicks an emote out the other side. Why the need for such massive caps? Well, because we charge these to 100 volts immediately before firing off. So the voltmeter will show, it basically turns on the power supply, voltmeter goes up, caps are ready, we trigger it for a couple milliseconds, and the volts just boom, drop right down. So all that current that's stored goes immediately into this coil, makes a huge magnetic field, bada bing, and then the magnetic field dissipates, and it goes through this massive diode that I've got sitting on the board here. So it's like a really good system. It's basically charge and fire. And that is controlled, oops, sorry. That is controlled by this circuit. This is essentially the circuit done in a very large pen. But we have an ESP, then we have opto-isolators, which I've got running high side and low side switching. I think they're okay for that because I don't really know of PNP opto-isolators. Opto-isolators are optically operated transistors, and so I have a pull-up, which will have this will have a resistor on it. It just doesn't show in the small font. But I have a pull-up and a pull-down, and so the pull-up and the pull-down do the initial state, and then when this is activated, I will be either applying 5 volts or applying ground. So I think that's okay. I'm not sure. Ben Gizmo will come in and start annoying me by being correct. I am very much annoyed by Ben Gizmo always being correct about what he's talking about. You can't do this because of XYZ. And I'm like, no, of course I can do this. I'm like, oh, you're right. So yeah, we have 5 volts there, and that's connected to a pull-up resistor. So when this is inactive, when it's unswitched, we're pulling up to 5 volts, and then when it switches, we are pulling current through here in order to make this at ground potential. Because when this is at ground potential, this is enabled. So when it's at ground potential, it's enabled, and typically we'll have it disabled. Yeah, those darn engineering types, they always pat their own egos by being correct about things all the damn time. But they're always insufferable about it. Big Gizmo's careful. He knows he gets under my skin. I tell him when he does, too. I tolerate it because he's always fucking right. It's so annoying. I would have had so many explosions on stream. Although I think my ego would have been completely deflated at that point. I did just enough electrical engineering to decide to go into pure physics. That way, that's on a more fundamental level. You're probably no more than the electrical engineers then. The thickest of capacitors only. Yes, the thicker the cap, the bigger the bang. By the way, when you're running with analog electronics and you're putting capacitors and stuff, heed my warning, chat. While it is fun to be like an Uo's lab, which you should check out, Last Miles. I'm interested in hearing your opinions on Uo's lab. If you check out Uo's lab, he's always doing something crazy. Sometimes doing something exciting. Sometimes he's messing with giant capacitor banks. Heed the warning. If the capacitor is the size of a shotgun shell, it can go off with the energy of a shotgun shell. You want to be cautious around your big caps. We don't have bleed resistors on this yet. I built this over the weekend. This is part of my homework. I made the bank of capacitors using desoldering braid. I made sure that there was plenty of copper here because I don't want that part getting hot. If this part gets hot, it'll warp the board and eventually make cracks. Cracks usually lead to there being a tiny amount of copper, big current flows, fire. So yeah. No way does a pure physics, material science, oh, MS. I know a materials engineer. Materials science guy know more than the electrical engineering guys. Okay, so this is different, slightly different. It wasn't electrical physics. It was materials physics. I know a little bit of materials, but only a little tiny bit. I need to put some hot glue between these because currently, like, this is bad for the circuit board. But this is like ready to go. High current capacitor bank. It's nice and flat. I can put my wrist across this and get a giant burn marks shock. But I'll have to devise some kind of a cover for it at some point. But that's done. We have the capacitor bank. I am concerned about the thickness, my sickness for thickness. I am concerned about the thickness of the wire here. The crimps, these are usually good for like 1 amp, but the crimps do taper down to a thinner piece of metal, and then there's not a whole lot of copper in these wires. These wires are capable of getting pretty hot, though. They are silicon jacketed, but I do have concerns for what's going to happen inside of here. I've burnt JSTs before, and it was on a power supply that looks very similar to what we're building here. Do you recommend an isolation barrier between those conductors on the back of the cap series? Isolation barrier, what do you mean, like an MOV? Well, okay, so what's going to happen is this is a very large and very dangerous amount of capacitance. I've put little marks on one of my favorite screwdrivers. There's 2 little tooth marks on the top of this one because I discharged this at a low voltage. They do look weak. No, this is a powerful capacitor bank. This is a lot of energy that I'm storing here at 3 shotgun shells, right? What we're doing is we're using the enable pin on the power supply to turn 100 volts on this thing only for the moment that it's needed. I'm not storing it there permanently. That way we get this nice theatrical charge up, fire, charge up, fire. That's the cool part about this. So when this is just hanging out, I think it's at a 5 volt potential. So it's not gonna give me that 100 volt shock. The wires look weak, not the caps. Yeah, the wires may get hot. I don't know. We'll test that if we get through it today. I still need to wire up a couple things on the control board. We've got opto isolators in effect between a 3 volt and a 5 volt system, and then the 5 volt system is switching on and off all the stuff. So we just need to do a couple more little soldering jobs, and then this thing will be ready for testing. What's the difference in characteristics if you use something like a supercapacitor? I'm not sure. I haven't messed with supercapacitors. Supercapacitors hold like a lot of volts for a long time, and then these probably have more of a bleed off current inside of them, I guess. I don't really know. This isn't a supercap project. This isn't a supercaps are like a different thing. They're for like, I don't even know what they're for. Are your silicone jacketed wires copper or aluminum? They're whatever you get off of Amazon. I think it's silvered copper or something. They're not aluminum though. Aluminum wires are only to be used in like hot places. So if you've got like a heater that you need to connect to, you would use an aluminum wire because it bleeds off heat a little bit better, right? But aluminum wires aren't flexible. You shouldn't be flexing aluminum because it fatigues way easier, even if it is stranded. And also, you can't really solder to them without special fluxes. They're silver in color because I think they have a coating on the copper. Oh, a line of rubber or a glass rod. You know, I've gotten away with these caps being in this situation under 200 volts, actually 150 volts. And the thing about it is like, these little gaps are very small, but they're fine for 100 volts. They're totally fine for 100 volts. This is isolating enough. I would have liked it to be a little bit more isolating, you know, like that would be a little bit more isolated. If I put a plastic cover over it, that protects it from the human. But this is enough of a gap. If I really wanted to be crazy, I guess I could go over the whole board and drill out all these pads so that there is a significant gap between them. But there should be no arcing at this distance. It should be fine. I'd asked with a mixture of aluminum and copper wiring, and it was a nightmare in maintenance. I can't even imagine. Never doing that again. Back in the 60s, it was not uncommon for a house to have aluminum wiring. My experience with aluminum wiring is having it on the 3D printer bed, and I didn't put a flexible wire on the bed. I just put the aluminum wire through the drag chain, and so as the printer did its job for the next 6 to 8 months, everything was fine until suddenly my prints started erroring out, and I'm like, why are these erroring out? It turns out when it was calibrating and doing its distance measurements, the bed would suddenly cool down unexpectedly. And I watched it doing a print once. There was a visible spark inside of the drag chain. I was like, oh my God. So the thing with those heat bed, they may give you a lot of wiring on the outset, but that's not designed to be flexible. Don't flex that. You want to do like a Euro screw terminal like this and put the heat bed over to flexible wires. Recharged power disconnected for a period of time. The filtering, I would assume, would do blah, 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 blah. Oh, filtering caps. Yeah, filter caps are designed to go quickly. They do quick jobs of holding and releasing electrical energy. Geosciences guys will know that the bonding between aluminum and copper is not pretty after some oxidation happens. Yeah, so that's sort of the whole thing behind putting ferrules on the wire and then crimping them using a screw, because you're not going to be able to solder them. And even in some of these 3D printers, they'll have these little tabs that they kind of crimp the two wires with. All right, so anyway, the capacitor bank is done. The voltmeter has wires on it. Voltmeter is not a high current moving device, although if anything shorts on the voltmeter, these will become my fusible links. But that's fine. That's okay. We can live with that. So those two are ready. I have connectors on the perforated prototyping board. I have all of the high voltage stuff on this side wired up. All we need is a big resistor going to the tip 122, and then we need to do the 2 opto isolators. So we've got our 3-volt system over here, our 5-volt regulator, 12 volts coming in here, 12 volts needs to go to this, the power supply that goes on top of this stuff, and then 5 volts from the power supply over here needs to go over here, and then 5 volts needs to go to our ESP. So we've got a couple little things to kind of get together until we're ready to go. So I'm gonna get this into the big vise, and we're gonna see where we want to actually start wiring this stuff up. We probably should look up the opto isolator again and see what circuits are suggested if I can actually perform this sort of high side and low side switching. I've already got it wired up right now. What is that one doing? Wait a minute, are they both going to the same thing? One of them is going to shut down. The other one is going to ground? No, what is that? Okay, let's see what the pins are here. Oh, I'm gonna check glucose level. I guess I can't do the BG overlay right now. I don't have a button for it. Oh wait, unless over here, wait. Let's go back and go to overlays. Over here, boom. There we go. Yeah, 230, that's annoying. I feel very saturated with glucose. Okay, so I had a neighbor whose brother is in the hospital right now. Her nieces and nephews, I guess, found him with a glucose level of 800, which is not good. That is like super DKA. So here's our inputs, and it's VIN, shutdown, and then ground. So this is our shutdown, and then this is our VIN, and that's ground. This ground, I don't want to immediately connect over to the high voltage ground, even though I think they are. Yeah, there's just a big ground plane that goes across the board. Here's our high voltage ground. There's our regular ground. Yeah, okay, that's annoying. So maybe I will just connect it from over here. I'm sort of wiring this thing backwards. I know, you could use his blood as pancake syrup. Crazy. I can't even imagine being like that with my diabetes. So what I've got wired over here is I've got 5 volts and then 5 volts with a 10K pulling it up. And then over here, I would be connecting to ground. So let's do that connection. I'll do it with a black wire just so that ground has sort of a consistency and coloration. And then we can also maybe move it over here too. I guess with this board, I'm going to avoid doing a lot of sort of the stuff that I did up here, where I've got the voltage that's directly down on the board. I needed a thicker trace for these. This is high voltage on both of these pins, and like high voltage and ground on both of these. They're like right on top of each other. It's kind of a little scary, but I guess it's all right. I guess it'll be all right. If I say it'll be all right, I guess it'll be all right. I get some scrap wire here so I can start wiring everybody up. This always happens. I start one of these things and I get so far with it that I get annoyed, and I'm like, I need to redo this with an actual physical circuit board. So what I'm going to do is strip off the very tip of this wire, like that, using my fingernails because I'm lazy. And now I've got a little tiny end of wire. I'm going to poke through here, and then we have to go to the other side of the board and fold it down onto that pin. So over here, and then we fold it like that. Now I need to solder it there. This is unfortunately a bit of a time-consuming way to build things. It's one of many, many techniques out there. It's the one that I'm comfortable doing. Unfortunately, I'm not very fast with it. And I think if I could somehow invent a pair of tweezers that would strip wire, like just have a little nichrome wire on the end of a pair of tweezers, that would make this technique so much more viable. I need to hold that still while I solder it. Okay, hold on. Let's just put this, move it over like this. And then I'm actually going to solder right here, even though the advantage to the technique that I'm using right now is that if I came from here, you'd be able to see the color of the wire that comes into there. So it'd help you troubleshoot things a little bit more easily. Fly on easiness. We can just do whatever. Ah! Messed it up. Doctor called my wife. What? What am I reading? You were 1,200? Oh my God. When you got diagnosed? I got a phone call from the doctor insisting I go to the hospital right now. Do not pass go. Yeah, seriously. That's nuts. That's a crazy glucose level. I don't think I've ever been anywhere near 800 or 1,000. I think I was like just normal hyperglycemic when I went to the hospital. I don't really remember what the number was. I'm going to go down up here just to be consistent with the way I did the other ones. We have a lot of space on this board, so I can be kind of fancy with my wiring. That's the other thing about diabetes that's sort of insidious, is that the human body is a machine of adaptation. And so you end up adapting to these high glucose levels, and that feels normal. So that when you start recovering from them, the normal or even hyperglycemic, but still closer to normal numbers feel like hypoglycemia, and hypoglycemia feels like starvation. And so you feel like you're in an emergency situation where you are starved. And so that's what a lot of sort of the bad diabetics, the people who ignore their diabetes willfully, get away with. Their body feels normal, but it's very, very bad, and it causes repercussions over time. Because the immediate repercussion is that you feel like crap for a while until your body acclimates. The long-term repercussions are serious and terrible. A lot of nerve damage. But that's why people are so rude. They always come up to you and they're like, my aunt was diabetic and her foot got cut off. And you're like, thanks. Really needed to know that. I love that everybody runs up and tells me that immediately. $500 or $600. Get into ketoacidosis. Yeah, you get into ketoacidosis eventually. What's up, Gonad? Hey, look what I got working. Look what I got working. Ready? If I put this up, hold on. Where'd it go? I put this up, and if somebody says, and it goes away. It was a lot of, I basically made a whole scene that has all my overlays in it. So I moved it back into scenes, which I don't really like, because that means that no matter what scene I'm on, this is always in the same spot. I could do transforms with these and like move them around, but right now what happens if the chat message comes in, and if it contains start soon, it checks to see if that scene is true, if it's active. And if it is, the flow continues, and then it turns on and off. It sets part of the payload to start soon and start sooner to the Java object that contains all this information. And even though the documentation said that scene item ID was optional, I have to have it in there for some reason. It's very obnoxious, this plugin that I'm using. So if that, it sets one on, sets one off, puts a delay in, and then after 5 seconds, it sets them back. So that flow is now done. So if people complain that start soon is up, it'll petulantly make it enormous on the screen. Saw my finger and suggested I go check it out. The next day I got a phone call. So your finger, weird. Nope, it has to contain start soon or start soon. There's two different ones that it triggers off of. What are the two? Hold on, let me check. Contains true. It's, yeah, start soon and starting are the two words. I'll leave it up just so people can play with it a little if they want. As a treat. 1 kiloohm for the opto isolators. I think under 3 volts, that should be enough. 1 kiloohm might be a little bit too much, but I think I've seen people use a 1 kiloohm. So 102 versus 103. The 102 here is on the low side. That is going to this pin right here, which is very close to our high voltage. What up, Jeff Devaney? Devnell? Nell. Dive nail. All right, let's get a purple wire. We're going to use purple. What if it was purple? Purple wire. So this technique is not like the only way to do this kind of stuff. It is rather slow. It makes a pretty organized board. This is wire wrapping wire. So wire wrapping wire. No, this I just finished a Node Red flow that does something with the start soon text. So I have it up right now just to trigger somebody and make them mention it. This is a Darlington array. This is able to switch high voltages and high currents with very, very little input. So we have basically what equates to 2 transistors. And so this is wire wrap wire. It's solid core wire, and I use it as basically the traces of the circuit board. This is just one of many techniques that you can use to wire up a circuit. I think it would be irresponsible to have wire on the top side of this because then it gets close to what is the collector here, and this thing is held at 100 volts when it's charging up. So we need to kind of like politely isolate stuff out. So what I'll do is I guess the purple wire is just going to directly connect, and then I will route it down to like here, to row L. It actually needs to go here. So how can I make it turn? Yeah, we blew up one of the transistors, so I decided to put it on a screw terminal. This thing, it can do a maximum of like 120 volts. And so just to be nice to it, I guess, in case it overheats or we do something stupid to it, I have it on a screw terminal so we can move it out. I had one of the instances of the thing switching. It was held at 100 volts. It wouldn't unswitch. I think maybe because I think because the the solderless breadboard is a little iffy with some of its connections. And in a 100 volt switching circuit, you kind of want those connections to be pretty solid. That's the whole push behind building this thing. All right, I'll just show you what it does. If somebody says starting or start soon, I do that. And I only just got this functioning, so that's why I wanted to show it off. I'm going to turn it off now. So now it won't activate when you say stuff like starting, no activation, because the flow is not active. It checked to see whether or not it's true or false. Yep. I don't understand why people, okay, you might not understand, but you might not get it. This is what it looks like when I'm streaming. I am sitting at this desk, and I have 3 huge monitors sitting above the desk. And on one of the huge monitors, I have the output, because it would be incredibly irresponsible to stream without an observable master output. I think some streamers do that. They alt-tab and have something on top of OBS like their game. That is wholly and completely irresponsible. I have a master output. It's not coming from the broadcast site, but it is what I'm sending. So, I know when things are active and inactive. Most streamers do this. Doing camera stuff with no preview. Yeah, how can I adjust all this stuff with no preview? It'd be crazy. It'd be crazy go nuts. My scenes would be all over the place. Okay, so let's get the purple wire in here, because what if it were purple? That's unfortunate I can't bounce out of here. I'll have to, well, if I do a right angle there, it's going to kind of be bad. So maybe we'll scooch down here and then back up. That's a weird way to do it. I mean, it is just switching at 5 volts, but you have the big monitor to monitor. It also keeps my back straight. The 100 macro buttons and 6 cameras. It's only this, but I've got a couple scenes of that. I do want the Stream Deck XL to work, but the I have 4 cameras and a thermal webcam. This is all the cameras that I have. They're all webcams. They're all Logitech, except for the thermals. The thermals. Look at all those veins. You can trace them. Actually, I think I need to get blood drawn soon for iron. I haven't done that in a little while, and I'm like, wait a minute. Now, this is the 5-volt system. It is opto-isolated from our 3-volt system, but I really don't want 100 volts getting back on this thing and blowing up my ass. So I don't want to really route it around here. This is where all the 100-volt stuff is going on. And unfortunately, I had to skip over a line. If I flipped this over, I guess I could probably have done that, but I just wanted it to work. It's a little close for comfort on the 100 volts, but this needs to get to here. But if I do a bend under here and I just bend the wire like this, then it is a free floating wire and it can catch on stuff. So if I go down here and I do just a little juking around, I think I can. Yeah, I guess it'll have to go the circuitous route. I should have probably had the opto isolator like here. I could put it down here. That's all right, whatever. I wanted things to be away from each other. So this will go over here to that pin, which has a nice distance from all of its buddies around it. I guess I'll do 2 pads for it. This is where I need that like heated pair of tweezers. I gotta invent that someday. Soldering comfort. Move this over here. Let's get back on screen, and there it is. There it is. Ooh, there's a lot of mass on this pin. It takes a little while to solder. Oh, and I guess I kicked the circuit board at an angle. What's going on there? Okay, so this vise I need to put in the milling machine, and I need to mill a little shoulder onto these clamp pieces, because boy howdy is it getting annoying. We could do that right now. No, I won't do the milling right now. My milling machine isn't quite properly set up, and if I'm milling on a vise, I want to make sure that it's perfect. So there's no issues with it down the line. That doesn't strike me as soldered. I'm going to add a little solder to the top here, and then it's going to inevitably heat up the other pad to be hot enough, and they'll both slip off. No, okay. All right, so that's definitely connected. So we'll take that and run. So I will go here. I mean, it's still going to be close, but I'm going to stay outside of this. Well, actually, let's go here. Yeah, this will be a little further out. Basically, I'm using the circuit, the perforations as like a horizontal vertical via arrangement that you would have on something like a very amateur designed PCB. I guess we've seen a lot of professionals that do that too, where all of your vertical moves are on one side and all your horizontal moves are on another. I think that's it's a little bit basic, but people get it done and they're happy to have it. So we need to go up to, that's 103, that one's 102. So we actually need to go up to, these are in a bad order. I think I'm going to rearrange those. The 103, the 10K, is going to be our pull up. So that one's going to go to 5 volts, or actually that one goes to ground. 10K goes to ground on this one, and then the 102 is our trigger. I mean, maybe we go up to here and just go straight over. I guess that's the way to go. So one below the hole, the giant gaping hole in this thing. That gets us very close to our high voltage section. Why did I do this? I guess it's fine. It's far enough away. Far enough. You know, maybe something will explode and I'll go viral again. I'll get another virus. Hey, why did that fall through so much? There we go. Yeah, I don't like snaking around this much. Just reserve a cap and put lots of voltage through it. What? That's what we're doing. Oh, reverse. Yeah. The viral clip that I have is of me putting 52 volts on a 30-volt cap by accident, quote unquote. And you can see it on the thermals. You can see it heat up and then explode. And I go, fuck! And that apparently went viral. I got 70,000 unique views in like a couple days. It's the only time I've ever gotten something to go viral because I wear a lot of medical technology. I don't know if you guys know this about me because I'm constantly fucking talking about it, but I wear a lot of medical technology and I don't want it to stop working because these things cost quite a bit of money. Even though they're disposable, they cost quite a bit of money. And they say, hey, with insurance, it could be as little as $35 per pump. It's like, no, it doesn't quite work out that way. Insurance is getting worse and worse every year anyway. But yeah, so I wear these devices that don't particularly enjoy getting their asses fried by 100 volts DC. So I tend to be a little bit more methodical about my my machinations on craziness. I think you guys mostly want me to be around for a while. Although, when I did the chat-controlled tank bot, and I gave chat the ability to move it around, and I put an X-Acto knife on top of the tank bot, I think some of you showed your true colors, your murderous true colors. Because some people want to be dead. They're like, I want Bother dead. I want him dead. Get him. No implants, not implants. They're adhesive devices that go on my arms and legs and stomach. Having you around is nice. Do more of that. Yes. Let's see. So that would be the output of this thing going through a 1K. Oh yeah, 1K so it doesn't blast this thing with all the current of 5 volts. So it's going through a 1K ohm resistor. It really suggested like a 200 ohm for the other side of the opto-isolator, but we're going to stick the 1s and 10s. So this will go to ground through the 1K because the Darlington is active high, and I just dropped everything down. Darlington is active high, so we are pulling it low while it waits. So we need to have a ground over there. Yeah, I got a Tesla coil one time. I got a Tesla coil with the 3D printer when I first got my Creality printer, and we activated the Tesla coil, and it worked for just a little bit, and then everything turned off. Everything turned off. So I was like, maybe we don't mess around with the Tesla coil. These are both grounds actually, so I can just run an exposed wire back to that. This kind of defeats the purpose of the opto-isolator, doesn't it? No, I don't watch Electroboom. I don't watch a lot of the creators that do the same thing as me because I don't want to take on their memes. Now, if it's like a smaller Twitch streamer that does the same thing as me, I watch those guys all the time. You know, I lurk in their chat rooms, which is another idea that I had that was totally toxic. I want a thing, and I don't know if I can do this through Node or if I need to like program my own bot to do this. I want something that goes through the list of chatters on the channel every now and then, and it checks to see who in my chat has the largest number of followers, and then it'll display all of their information up on the screen. It's so toxic. This feels weird, what I'm doing right now. This is not great. I don't know if I should be putting a diode in there, but both ends of my opto-isolator are connected to the same ground, which begs the question, does that then invalidate the ground? Should I be putting a diode in there or something? Let's look that up. That is toxic. Exactly. No, but there's people lurking in chat that might have more. I've had Twitch report to me what my most popular viewer is, and there were some VTubers on there. There's like a VTuber that does electronic stuff, and I guess they or she was watching, and somehow Twitch keyed into that, and it told me on the back end. And I was like, wait a minute, that's like very, very, very awful. Like, they should not be telling me that information. I shouldn't get that information. And so I think it would be hilarious to be completely toxic and just make a little thing that has like a light on it if they're over like 100K followers or something, and just it'll display the name and the number of followers of the most popular chatter. I think that would be hilarious because it's just, that's so toxic. It's so toxic. Ever get it rated by somebody with 6,000 plus viewers? I just stop talking and tell people go away. No, I do a lab tour when that happens. Rob Oz is rated, and he's like a 1.5K streamer. He's also a friend, you know, insofar as you could befriend a Swede. It's a bit standoffish, but we are friends. But so he's rated a couple times when he's like rage quit, because he streams during the day like I do. I stream during the day because otherwise, what am I doing for a more Euro crowd? So I don't get as many viewers from that as well. So if I went a little bit later on, but I have stuff to do. I got to feed the dog. I got to cook dinner and walk my parents. I don't know, evening stuff. You know how it goes. So I have stuff that I need to do in the evening, so that hurts my evening streaming abilities. I could do, if I streamed through dinner time, which I do sometimes when I get the house to myself. When I stream through dinner time, I get lots and lots of viewers. It's like a real nice place to be. But no, we get fewer viewers. Do I have a logic analyzer? I'm looking for it right now. It's in a drawer. I have two logic analyzers. One of them is one of those little $14 ones, and you can use those with the suite of like really nice, everyone is eating and lurking. It's the best time to watch Twitch. One of them is a little $14 jobby that I can plug into the computer and then run logic analyzing software on. That's a really good place to get a logic analyzer and learn what they do and how they work and how to use one, because you're only in the tank for 14 bucks, right? You're only down 14 and you get all of those channels. I don't know where mine went. It was in here. And it's pretty easy to install the right drivers and stuff. You just have to look it up. Technically, you are stealing from the logic analyzer software people who want to charge industrial prices for the logic analysis. Don't worry about that. You're a criminal. It's fine. That is also a logic analyzer, but it's a $1,000 oscilloscope. Now, keep in mind, Rigol makes some very cheap, not cheap, they make inexpensive oscilloscopes, like $400 to get like a professional oscope. You can also get oscopes that are like entry-level China stuff that are much, much cheaper, and you'll get by with them, right? You'll get all the functionality out of it that you need. So what is the speed limit of those small price logic analyzers? You'd have to look them up. The specs will be on the thing. I do not know. For my intents and purposes, it's usually reverse engineering some kind of a signal in something that's not fast. Like, I don't need it to go fast. I just need it to have like serial speed. So anyway, that's what I have. I don't know where it is. Anyway, we gotta do work. I gotta do work. So with this thing like this, we got TXRX, we got all these inputs, and then ground is the second one over here. So 5 volts and ground are all the way down here. Yeah, so I'm gonna have to run that ground. Oh, that's right, the question. Separate grounds of optocoupler and DC. 24 volt input, don't look at that. 24 volt input, DC to DC, output 3 volts. 24 volts also pass to an opto. This question stinks as it stands very vague. It needs a schematic. It's what? Hard to say without knowing your application requirements of what you should do. And the DC-DC converter is not isolated. The grounds of the 24 and 3v3 logic are connected. In that case, there's probably no advantage to splitting them at the optocoupler. You're not really answering the question. And also probably no reason to use an optocoupler at all. On the other hand, if the DC to DC converter is isolated and that isolation is needed, then you would use an optocoupler. I'm using it as kind of a voltage shifter. Separating grounds doesn't always do that. I can't go into great detail without seeing the application. DC-DC converter, if you need isolation and you have a transformer, see your reason for splitting the ground plane. If there isn't a good reason, in most cases you're better off with a solid one. High frequency currents takes the path of lowest impedance. Splitting the ground plane usually increases the impedance for currents to return to the source. Better to keep them separated to avoid unpredictable ground currents. That's not what we're looking for. Yeah, it just feels a little weird to have the grounds connected to one another, but I guess we're just going to do that. Theory, ground, mega G pin. Just feels weird for me to have 100-volt ground and 5-volt ground to be sharing one another. If I need to have like a diode or something. Common ground when using an optocoupler. Oh my God, get out of here. Working on a small Arduino project, that's where it always is. Involves using the car's door to initiate a task. Door trigger wire usually holds 5 volts, unless the car's in blah, 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 blah. And then there's the thought about the circuit. From what I've learned, optocouplers are useful to isolate the microcontroller from the trigger source, but as you can see, in this case, the grounds are all connected together. It would see the easy solution is to have an isolated 12-volt to 5-volt DC power supply for the controller. These answers always just drain the life out of me. RECU, DC to DC, galvanic isolation. What? They want like a DC to DC converter so that you can make your own DC source. I don't think I have any of these. I think I used to have some. Used to have some of these DC to DCs. I think I still do. Wait a minute. Hold on a second. Hold on a second. So one of those things I have in the corner, but I don't know if it's, I think I might have gotten rid of the ones that don't do conversion. Here they are. So let me see here. These jobbies. Be really lucky if this is 5 to 5. Made in Mexico. D0061A 9349. D0063A. Was that right? 61A. DC to DC. It's a relay? It's a relay. No. That doesn't really help. That is a relay. DC load and control, 3 to 9 volts, blah, 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 blah. Oh, look at you. Wait a minute. So it is an isolator. Well, it's unfortunately not really what we're looking for. Cool though, it's pretty cool. Plus and minus DC coming from, okay, so it's just, yeah, it's just transistoring them. And it's got an internal diode. I don't know what these external diodes are all about. Maybe those are flyback. Weird. Okay, so that's not what I thought it was. I thought this was a DC to DC because I had a couple that were in sort of these weird epoxy containers, but looks like I'm SOL. Any of you speak up if you're a DC to DC converter and you're in this bin? What are you? Any of you 5-volt DC to DC? What's up, Silly? How you doing? Wait, what the fuck is that? What is this thing? Hold on a sec. Wait. Microtran. UM32M. 1500 ohms, CT5. What? 5 milliwatts, 50 volt RMS test, plus 2 dB. Is this like a toroid? What the heck is this thing? Let's just look it up so it'll tell us what it is. Microtrend UM32M. UM32M. On eBay. Online components. Well, what are you? Data sheet. What the? $263.94. Is this like a technical audio? Wait a minute. Bunker of Doom. What the fuck? Okay, it's a transformer. It's like an audio transformer. Transformers listed on qualified products, blah, blah, blah. Oh my God, it's one of these. There's no information. It's just a bunch. That may be it. Yeah, that is. This is the only information we're ever going to get. Mill designation. UM32. Primary impedance 1500 to 600. Jeez. 500 milliwatts. Is it from 1980? It might be. There might be a date code on this. Just put a lot of information on it. Now it doesn't look like we've got a date code. This thing could be older than I am. It might not be though. 5 milliamps DC or 5 mega amps. Yeah, that's cool. All right, so it's a little transformer. You know, hey, maybe we could make it into an isolation transformer, but we would need to convert to AC first. So this is going up here with weirdo transformery things. Yeah, I think the odds of my having a DC to DC are low because I think I've gotten rid of a bunch. I think I got rid of a bunch that were used for that research project. Yeah. Well, but the problem is they're going to miss something. They can't put all of the information on the package. It would be nicer if they had a more readily available data sheet, but we at least saw a catalog from Microtran. Bunker of Doom. Oh, okay, so that's actually just the same thing. Neat. It's going to be the same thing, electronic design, 1960. 1960? Oh my God. Can't get, it won't scroll. Oh, because it's just straight up a scan. Ah! Oh, this is images in the Chrome PDF viewer. It's not going to really be scrollable because it slows down the reader by like a huge degree to have these enormous images. I wonder if they've got circuits in here that would be fun to build. Though the problem is we found that giant book of circuits, which is good for inspiration. But the problem is a lot of those circuits aren't really fleshed out. Those catalog circuits will give you very little information, which is what we found. We did a couple Fridays where we tried to build something from the circuits book. We found something cool, like an Anoyatron or any of these other things that were very analog early electronics design, and couldn't build them because I just didn't have the components to build it, or they were vague about something that you need. It's like they had a circuit in there that was how to set off a nuclear bomb. And you're like, cool. And they're like, you need this radioactive vacuum tube that you can't find anywhere. I think somebody like Mike's Electrics had one. It'd be so cool to have one of those. It's basically, if you have a super duper duper high voltage, you can set it off by exciting whatever space in between there is, and it'll suddenly go off. No, it's different than that. It's like a really high voltage, very rapid switching switch, which is apparently a big component in sort of the suddenly everything happens all at once nature of a nuclear bomb. That's apparently a part that's very hard to get right, is the suddenly everything happens at once. Because if you have something not happen all at once, then there is a hole that all the pressurized stuff is going to get out, and then it won't go critical. All right, so the answer is everybody is too persnickety in order to tell us if we can put like a diode in there or if we need to put a filter on it of some kind. And it seems like you're never supposed to use an optical isolator. I'm using them because they're pretty generic, and I've got a couple in a drawer. And it also allows me to do a little bit of level shifting on the 3-volt line. I would have liked it to be a little bit more isolating so that we weren't connected to the same ground that everything else was, because there's a very strong negative voltage that gets thrown back into the system by the coil. But it seems like everybody is a little bit too hoity-toity, and they tell you, yeah, you just shouldn't use one, or you suck, or this question is bad. That's all we get. You can do this without the opto. I'd like to control 12 volt, 1 amp, 1.5 amp solenoids by switching a MOSFET with 3.3 volt Arduino. I use an IRL Z44, the IRL series of FETs, and do this, do this directly since it is a logic level MOSFET. MOSFETs are pretty good. They're a little bit fragile. You got to be careful with your use of them. I commonly see this type of circuit isolated with optocouple, unnecessary for my application. Lastly, the project board will be going into a vehicle. You are correct. You can do this without the opto. Yeah, everybody's like, don't use optos. Thyrotron. It's got some crazy name from the vacuum tube era. Yeah, it's like 50s sci-fi names. But we had, like, one of the circuits in this book is calling for one, and I'm like, this is not something that we can build, Chad. This is not something I can source without having an FBI agent breathing down my neck. Yeah, exactly. It's a something-a-tron. Doohickey-o-tron. It is insulated. Automotive power is dirty. This is what I'm talking about. We don't need quite that much isolation. We're just trying not to get a spike going all the way back to our 3.3 volt line. And I don't think it will. I think that might be the advantage, the only advantage of using the optocoupler, since we don't have a unique isolated supply. I can't even do that because the voltage converter has a common ground. Can't be the 60s without it being actively toxic. Yeah. They sell them in my country. Interesting. Legalize nuclear bombs. Shadow Wizard Money Gang. We like casting spells. Arduino, LCD GPS, blah, 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 blah. Yeah, I don't see anything about like putting a diode in there or something. I guess what that does is that kind of routes your ground through that circuit anyway. See, here they don't even address that the MCU might be using the exact same ground as everybody else. If this were constantly USB powered, maybe it would be something that could be done, but it looks like, yeah, then a power isolator would have to be employed, which I don't think I have any. I think I used to have DC to DC converters, and I think I lost all of them. Only certain watches, they were expensive. Only certain watches were radioactive. They were the expensive ones. I mean, if I could put I don't think it would be useful to put a DC isolating capacitor in there. Close the window. It's very breezy outside and it got very cold. So I'm like getting goosebumps while talking to you guys. So there's not much I can do without a DC to DC converter. So in light of that, I guess I am just going to be connecting ground to ground across this thing. It just seems like kind of a waste. And I guess it just is. Yeah, the tritium for glow in the dark. I have gun sights that have tritium on it. Although I think it's probably gotten dull by now. I had to write the manufacturer and be like, these are too dull for the age, and they're off by a little bit. Everything's to the left. And they're like, I got a real snippy letter back when I sent it in, and it says, corrected it, it was only a little bit wrong, and replaced the sights. I'm like, good. Like, thanks. I'm so sorry that my skill in target shooting is better than whoever's setting up these things, because it was consistently just a little bit to the left, and they didn't believe me. But those sights have, they're little glass vials with a little tiny bit of tritium in them. The knife may be better for this. This is like sewing. And I remember my teammates on my senior design project were like, oh, haha, look at this guy sewing. And I'm like, dude, this is how you do cool stuff. Like, I don't know why they got such a kick out of it. And I think it's maybe because they were associating sewing with like being a really feminine thing to do. It's like, why? Why is that? Like, jeez, stupid people. They were very stupid. There was one of our papers for our design project had to be done, and so one of our teammates was like, "Don't worry about it. I'll do the." He was like acting like a used car salesman. I'll do the paper. Don't you worry about it. You don't have to worry about a thing. I'll get it all done for you. And so we looked at the paper that he wrote, and it looked like it was fine. It was great. Cool. It looks right. Everything seems to be in the right citations and stuff. Then when you actually read about it, our design project was to put a bunch of LEDs on a dancer and track their movement so that a flash animation behind them would respond in kind. So if it was like raining letters from the sky, they would bounce off of the dancer or go behind the dancer. They couldn't go in front of the dancer, but they would kind of like bounce off, and it would be sort of an interactive theatrical thing. So that if they changed up the routine in the dancing, everything would still animate with them, right? And that was a big deal. That was back in 2002. No, that was 2007. But anyway, so the report for that, right? You write a little report about what you did and how you came about the technology that you used and why you used the particular things that you used and how that works and stuff. And so the term paper for a dancer dancing around with a computer working on them started out in the at the dawn of time, mankind. And I'm just like, what have you written? It was crap. If you got into the details of any single piece of that paper, it looked right. It looked like a term paper, but you would be fooled because that was not a term paper. That was a vague, plagiaristic writing. It was kind of like an alien. Whoa, what did that turn on? I did not turn that on. Hold on. Oh, you know what? I probably grabbed it I hit it by accident. No, it may have looked like a term paper, but it was an alien making something that looks like a term paper. It was crazy. Those people in electronics, professional and hobbies, leaded. Yeah. What are we talking about? I'm still using leaded solder. 60-40 lead mix, and I didn't really mean to get that, but I've kind of stuck with it. Unleaded solder's come a long way. That's gotten much better than it used to be. Back when it was first invented, it got a bad rap, and everybody said this stuff sucks. And all the old school electronics guys back in the all the technicians were like chewing on leaded solder and just, oh, it's so bad. Airplanes are going to fall out of the sky because of it. Turns out airplanes were going to fall out of the sky for other reasons, not unleaded solder forming whiskers. The formulations have gotten better now. So if you crank your iron up just a little bit, 700 degrees, mine's running at 666 right now. So if you up it to 700, you get pretty good flow with it. It's not going to be shiny, but it will at least look like it's wetted over the pads if you allow that heat to get in there and use it. It's fine. It's fine. But again, I have chat telling me that lead is practically healthy, which is ridiculous. All right, so the enable pin gets pulled to ground. So this one is at ground. So we just need ground to go down over to here. And sometimes I'll do the ground like out on the surface of everything. In this case, I guess what we're going to do is I'm going to pull ground over to here, and then we'll just pull ground down to where it goes. We'll just make a vertical thing, and then that'll go over to the microcontroller with its ground. Unfortunately, the opto-isolators are not as isolating as I thought they would be. If something gets back on ground and feeds back, I guess it's not going to have any incentive to skip this portion. So we can blow up the 5 volts. It'll still be connected to ground, but hopefully it does not find any throughput. That is a purple idea light that just turned on. You guys missed it because Last Miles gifted 5 subs. Last Miles, thank you so much. Went to Esports Are for Losers, regular. Crispy343, Nightbot, Magic String, and Dr. Plugger. Well, I could use some magic kissing right now. Thank you so much for the 5 gifted subs. That is a very big deal. I need to move along and deal with a backup. Oh yeah, go do your thing. Thank you for hanging out. Last Miles, you guys, listen, I'm going to do another shout out because I have literally no shame. I have zero shame. I'm going to shout out Last Miles. Last Miles should have all the viewers, all of them. Every single one, every last one. Did it actually shout out? Oh wait, I didn't put a slash on it. I'm dumb. Everybody ignore that other message. You didn't see it. You didn't see that. You didn't see that shout out. You didn't. 10 gigabits for the background. Oh, that reminds me. The other purpose of doing all the light bulb stuff in Node-RED is to have a warning light for my server so that if the smart status changes, the light will go red. I need to figure that one out next. Because that's a big deal. I don't want to lose all my data. It's pronounced data. All right, so let's get this thing in here. Doing the same thing. I'll just do up on the surface. I'll do just a little hook. Or do I want to? I guess this one should have just gone across. Oh, whatever. Let's just bend the top here. Yeah, the isolator's not really doing a whole lot. I probably could have just put a transistor in there and gotten it just the same. It would have done just the same. I thought it would be a good idea to have isolation on this, but the only way that I'm going to achieve true isolated bliss is to kick all of my friends out of my life. No, I mean is to use a DC to DC converter instead. Because what a DC to DC converter does is it turns the DC into AC and then puts it through a transformer, an isolating transformer. So it turns all of that into a magnetic field with some, I think, some filtering on it. And then it comes out on the other end as its own independent circuit that is coupled to a magnetic field to the rest of your circuit. Ah, 100 bits. Thank you for the bits. Hey, that's mighty fine of you. I appreciate that. That's a whole $1. If I was more popular, I could get one of those make it rain things, little money things, and tie that into one of these systems. It's easy. It's as easy as just putting a motor module onto the thing, or just an ESP that will switch the power button. 20 cents with the Twitch tax, yeah. I used to go through all that stuff and balance the books. I don't make enough money. I don't think I need to pay taxes, although I usually owe money. So I probably have to go through and look at all that stuff, but I don't make enough to use the, you know, like bits and donations and stuff are still in the sort of a gray space in taxes. But one day I'll know if you put your full name into your PayPal, because I have to go through all that stuff. And I get to see the dollars and cents. Didn't think Twitch took a cut from bits. Yes, they do. They don't take a cut from channel points because those are fake. But for bits, oh yes. Oh yes, they do. And I get 1,001 transactions with people's real names on them. This ground plane is going to be a little bit crazy. I do kind of want to keep it out of the way, though. Why is it not doing anything? What are you doing? Solder. Sometimes you get like an angle that blocks all the heat. Yeah, bits are real money. Channel points are just how much you've watched. No, when you use your bits on the channel, Twitch takes a cut. I know this because I see these tiny little donations of like $1 or $3. And then out of that $3, like 68 cents or like some ridiculous amount gets taken. Bobbin! That just went purple. Or no, it went red. I don't know. It did one. I have a hype chest. Oh my God. Gambling. Gamble. Gamble. Spilled tea. It's better than a lot of emotes, I guess. Anyway, Balbin, thank you for the 14 months. I have to gamble. Wait, can I open it? What if I do it over here? Oh, it's the same one. Yoink. Thank you, Balbin. I really appreciate that very, very much. Did opening the loot box give you dopamine? Just a little tiny drippy drip. So I need to spend more real money to open more of those. So I get that little tiny, just a little tiny little drip of dopamine. That ground going to, oops, I went the wrong direction. What did I do? Oh, I went backwards. Ground is skipping over a couple things. I don't really like that. I like it when my circuits can lay out nicely, but I guess we'll just continue this way. I gotta get it done. This is one of those things where like building it perfectly is not the goal. Can't keep gambling it as a timeout. I really wish we would get a little bit more strict with our gambling rules around this kind of thing, because it's gotten a little ridiculous with these cell phone gambling apps where you're like, you never get away from your cell phone. You've always got it on you. And so they're like, cool, well, let's do a gambling app. And it's like, this is wrong. This is very, very wrong. Because I'm sure there are people who are losing their lives or losing their, so like, I don't know, social life. People lose themselves to gambling. They dedicate themselves entirely to it, to the point where they, I guess with the cell phone app, you can have your phone in the bathroom and then you don't piss yourself while sitting on a stool. But like, there's something wrong with that. Something ain't right. Manipulating that level of human psyche. These phone apps where you can gamble on like sports or whatever you want. They have these commercials where it's beautiful people winning lots of money. Who's regulating this? Yeah, gambling over the internet it's not good. But since, I guess, politicians have yet to catch up with even 10 years ago technology, nothing's happening. Legislatively. Plus, nothing moves in a positive direction anymore, so just get negative, negative, negative. That's all. All right, so now we need to go to ground on the microcontroller, which is the second pin up on this row. And then we'll hook up our Ds and stuff. And I guess those go to ground too. Oh yeah, no, I've already connected those to ground. Yeah, that's right. Okay, so yeah, I've connected to the ground, just not very consistently. I could have probably done them up on top of the whole board and just run it directly over, but I used wires just to make it clean. So in this case, I guess I'm going to hop out from one in front of it, and I'm going to go down to that second pin. So this will go from right here. We'll get that soldered on the other side. Actually, it should go from here. That'll get it directly to the pad. We're getting close. We're almost done. I mean, it's this, the microcontroller connections. This, the microcontroller, and then we jump over to the, oh good, look what I did. Why did I do this? That's ground, but that's not ground. That's why I did that way. Although I could go from, where's that one? That one goes to here. And it's bringing ground in from over here. So really, okay, we're going to redo that. That's skipping over stuff like that is not great. It just makes it so it's harder for me. So what I'm going to do is get rid of this, and we'll just do it on the surface. That was a bad idea. Bad idea. What's happening right now is that I can't solder to something without melting stuff around it. And since the connections are all associated with one another, it's kind of like a boneheaded move. What I can do is just drop this signal over to here and go up with it. And while that would have been a no-no if I had fully isolated stuff, because then we'd have a nice big row of holes isolating everything. This is just not isolated. The opto isolator is in there as sort of a nice way to convert the voltage. So I'm going to get this out of here, and we'll just do it vertically. We just cut it. I don't need to preserve these. It was a bad move. That was a bad move. Let's go back on it. Let's undo our mistakes and never speak of them again. So this is a ground, and I can get rid of the solder right here. Solder. Okay, bye. Come back here. Stupid thing. This vise is kind of slippy. Reset to 0 on that, although we may still use it. Okay, so ground and ground, and I guess I'm just going to come up from here with the exposed wire. And then ground is also the second one down here. So I can come over, up. Yeah, we'll do kind of a sloppy route to here. I'll just do that on the underside of the board. This feels a little better than the other way. Put my tweezers down like that, and then I do a run over to that side. And then for the bend, I want to anchor it right here. The unfortunate part about this technique with the double-sided prototyping board is that it makes big drippies on the other side. And I really need to find the one-sided square pad prototyping board. It's just this stuff is so prolific on Amazon and stuff. And I've got so much of it now that I can't really justify purchasing the stuff that I really like to prototype with. Because that plated on one side board is so good for surface mount electronics. I can build, wait a minute, I messed up. I messed up. That one is in fact power. That one is 5 volts. That would have been a big mistake. Luckily this is all undoable. All I need to do is just add a little solder there. And then let me anchor this corner down here. Yeah, where's my, okay, there it is. Anchor you in sort of a correct path. There we go. And then we're going to unbend that to help it bend out. It's going to have a little bit of a kink in it, but if I grab it here, just on top of this puddle, and wrench it over to the side, I can just kind of bend out that little kink, and it's still good. I gotta think that there have to be these horrible horror stories involved with online gambling. I would think that there are. There are horror stories in real gambling. They probably just work hard to suppress anything like that. What's up, Dutch Mania? How you doing? How's it going? How you doing? That's a little quiet today. We're kind of climbing up there with people. Got a good crowd. It was a slow start though to the Tuesday, and we're just doing like some soldering. It's just kind of a chill stream. But I've added some Node-RED stuff, so now I know how to activate overlays with Node-RED, which means I can tie them into chat, and I can have all kinds of cool stuff happen when certain things are said in chat, or bits are redeemed, or any of that sort of thing. I'll have to figure out more ideas of stuff that I can do, but I really don't like this stuff because now that I've done that, like it doesn't look like I have little bubbles of solder connecting these, which is kind of the purpose of the style. You have these little bubbles that are connecting everything, and then on the other side of the board, the trace is just, it looks a little bad. But that's just what this technique is. That's how we do. So there's that. This is 5-volt input. So this can go there. but I can't turn it around this. So maybe I can put it, that's a tough one. Well, maybe we can come out here and just go alongside this other wire until we get up here. That puts me over at the high voltage section, but it's 5 volts. I need to connect everything to it. So red wire, there's a red wire. We're sort of getting our grounds and powers done, and then we can get the signals done, and then we can test it. Yeah, gambling the retirement away in an afternoon. I once saw a GIF of somebody gambling. I guess it wasn't. It was just a video of some guy gambling, and the person recording was basically looking over their shoulder, and they were adding funds from a credit card, and they added something like $60,000 to this little video machine where they were doing like these little. It's incredible. It's called prototyping. Soldering like that is fine. I guess so. I suppose it should probably be on the underside of the board, and then it'll pop up right here. So let's go to the underside of the board. Let's do the 5 volt line. Yeah, so the whole purpose of this prototyping board is to hold things down slightly better than they would be in the solderless breadboard. And so this helps you kind of finalize your design. And this specific technique was something that I picked up on from the 3-letter agencies that I used to work for with the wire wrap wire and soldering it down to the board like this. Although that little hook I don't like. But it's a good technique. I mean, I had been doing stuff similar to this, but the wire wrap wire is a really good wire to run everything on because it's small enough that it really kind of stacks up on itself. I just lost the wire there. I lost it. Bring it back. Bring it back. All right, we're taking that up. Let me just trim the end of that. I hate this vise. I need to machine a shoulder into this vise so that it doesn't do that when I push down on it. How do people with that level of gambling addiction have such a high credit limit? They might have owned a business and retired. There are some people out there who are rich that you would not be able to tell. And gambling away something like $20,000 in an afternoon is nothing to them. It's crazy, but hey, the world's a very big place. Certainly not a position that I'm in. Let's go in there. Then it goes to the high side of both of these. And then it goes back to the 5 volt regulator. So we're going to take it up to here. I'm going to go burp, burp, burp. And then we'll be at our high side. So in and out one early. I mean, I could go out here, but then it would cover over stuff that I think I need to have access to. So we'll go out this way. Where am I going with this? 3. So we're going like just over here. It's a tiny little jump. Just a tiny little jump. A little jump. Okay, would you just go into the thing? Wait, is that going to put... that doesn't make sense. What direction am I going? No, because then I'm above the board. I need to be below the board to move over there. What am I thinking? I think my verticals and my horizontals are all messed up. How can we get over this? Go out to here and go that way? No. Let's see, I'm going horizontal with that one. And then I'm just thinking about how am I going to run this thing? I could go out on top of the board and go boop, boop at a right angle, but this thing is kind of right there. So I need to be under the board in order to do this. I really wanted, maybe I could just do a little, it's so stupid, do a little skippy and then go under the board like that. I guess that's what I got to do to preserve my my technique here and not have a corner on the same side. It needs to jump in order to move from end to end. This is stupid. My technique is breaking down with the way that I've designed this. Yeah, we had Last Miles drop a ton of gifts. I really appreciate that. So now that I'm here, I'm going to go to here. If I go to here, this is ground. This is our output to the 5 volt or to the Darlington. I guess what I can do is, actually, I can come up over here. Yeah, you know what? I'll do that. I'll follow the purple line. Technically, that's low voltage. It shouldn't get that close to anything high voltage unless the Darlington explodes. And I don't think the Darlington's failure mode is one that has that sort of danger associated with it. So if I come up here, I come out with this, then I can just go to the other pin up here. So we'll just kind of sneaky it right down here. Even though this transistor is right in the way. Can you just, or wait, this is the diode. The diode is just right in the way. Just sneak out of the way there for me, bud. So then that'll connect to 5 volts, and then we can jump over to the other 5 volts all the way up here. Wait. 5 volts. Oh, that's the, is that shutdown or is that VN? Because that VN is going to be 12. There's a lot of voltages running around on this board. That should not be, this should not be connected. Let me disconnect that before I get too far into it. Too far into it. This one should go to 12. So that one's going to drop all the way back to the connector. Tweezers and a soldering iron. That would have blowed up my circuit in a very unexciting sort of way. Just dig this out of here. Yep. Flippy. Clampy. That one isn't soldered yet, so it's still like that. And then this one, I'm just going to take out. There we go. That's where our next 5 volt jump is going to be. But for right now, get this out of here. Where is it? Oh yeah, it's on the other side of the board. I'll have to pull it out from there. Okay, so this is disconnected. That one is not needed. It'll get replaced with a different one. So just pull that out like that. And then this one goes down to here, just like so. And I guess I gotta see, this is why I need a pair of tweezers that has like a little nichrome heating wire on it. Just a little bit of heat, because this stuff is not that strong, but that could help me pluck the end of the wire off and solder it faster. Depending on how maneuverable the tweezers are. I don't know what the power supply would look like for that. That wouldn't be too bad of a project if my milling machine was still up and running. All the solder fell in and away from the wire. Come on. Do me a favor. There we go. Clean that up. I want to clean that up. Oh, it's not even you son of a bitch. Okay, so vertically is not going to happen here because these two are... oh, is this one not grounded? Ground wire? Or that's what this is. Yeah, that's the ground wire. Okay, so let me see here. It pretty much has to go down here through this little corridor. So I guess that's what we're going to do. So I'll take a red wire again, just because Color coding these means that my dumbass is not part of the equation. It means that I'm able to, at a glance, know what's happening in the circuit, where my stuff is going. Is this going to be under the IC? Yes. Okay, so we're going from here. I'll violate one of my design rules and I'll go crossways with this one. The worst is when that little end just falls through. It just goes away. And you're like, oh, bye. So apparently all the kids are obsessed with Serial Experiments Lane these days. Remember that one from the 90s? That old anime? But it's not really a good anime. I don't know. I don't understand. It's just like a Shinto, like, spiritual anime that was rebranded as 1990s style, like, message board obsession, right? They kind of rewrote it to be tech instead of Shinto stuff. And you could tell there were some, a 62-month keeper of maps seems like a lot of months. That is a couple months. That's a couple months. Keeper of maps, good to see you here. How you doing? Yeah, it's Serial Experiments Lane. Like great. My friend was obsessed with it in high school. That's how old I am. And it really was just oh, my iron turned off. A rebranded like spiritual sort of, because you can tell that like some of the stuff is framed completely wrongly. Like, for instance, somebody from a shooter game accidentally got into a kid's like school game, right? And they framed it like it was this horrible disaster accident. And it's like, wait, but no, just like some troll got into the chat room. Like, it really is nothing. It's like not, the internet is not real, but that was left over from when it was the other style of anime. But I don't know, the kids are going bonkers about it nowadays. I see a lot of content about it. Strange, very strange. This is not my favorite joint in the world, but I think it works-ish. I wish I could flatten this one down a little bit more. I'm going to take another stab at it, but if I get it wrong, the whole thing is going to move, or it's just going to get worse, like the wires are going to get a little bit more molten. I guess that's okay. Never heard of it? Your generation is obsessed with it, man. Wait, if I'm up here, that's not gonna, what was I thinking? Wait a minute. That's not what I should have done. Oh, okay, all right. This is double, I screwed up even more. This is even more of a screw up. This is unforgivable mistakes is what's going on right now. I don't know what's wrong with me. I will repent somehow, chat, and I just hope that you can find it in your heart of hearts to forgive me for what I've done. Meanwhile, my dog is barking at the door. Woo, 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 woo. There you go. Get that out of there. Ghost Stories dub. Yeah, that one is legendary. That one is legendary. Very funny. And apparently they love it. And actually, DBZ Abridged, apparently, like, DBZ creators loved it. It was just the parent company that thought it was unacceptable and would give them trouble. Even though it was completely non-for-profit. Those jerks. Oh my God, I wish my dog would shut the F up. She's going psycho at the door. It's probably one of her friends out there getting a walk. But it's very distracting to have the dog going just psycho in the background here. Although you guys can't hear it. And I don't think I'm going to be able to do a dog cam. That's a little too doxing. Is there another one? I've only watched the one redub. I think there was another silly redub, but some of them kind of lose the comedy. They go a little too hard into the comedy angle. You need to preserve a little bit of the show, because that's where all the good jokes are. Yeah, sign. Does it say? What does that say? Does it say riot? I can't read that at this distance. What are we doing? We are going towards this one, and we are going towards the 5-volt pin, not on this vertical one, because that is, or not on the horizontal one. This one, Okay, that one is the 5-volt pin, so I do need to connect to there. So I'll probably go here. And that can go over. Oh, was Madoka Magica a different comedy dub? I'm not sure. I don't know these things. I don't know these things anymore. I'm out of the game. I'm out of the game. I ain't gonna be pulled out of retirement until they become. No, I'm not gonna go into that. I'm not gonna complain about modern anime being terrible. Ask Fat about it. You watched a bunch of those series, and I tried to watch one of them, and I was like, this is just too perverted for me. This is just too much. I used to watch some pretty crazy stuff. Where is it? Here it is. There we go. No! What is it with malls and having the definitely unlicensed t-shirt booth? It's because t-shirt printing has come a long way, and you can just Control P onto a t-shirt and make you some good money. Okay money, not really good money. You can make money. Good or bad, still money. Shut up, wizard money. Huh? What's going on? Are you breaking, or are you? What's going on? Can you? There we go. The knife technique is not the best. None of these techniques are the best, actually, to be honest, but they do kind of work together to give you a functioning circuit board. Kind of. Having to do that little maneuver with the iron is always very annoying. And then this is a mess. We can expose some of it by plucking it. Oh, a little bit more. I got to get that plastic off of it. Otherwise, I mean, it is going to melt back a little bit when I do apply solder. So maybe we just do that. Goku wearing the Supreme jacket. That was supposed to be a joke. It's a meme. It's so funny. Goku drip. What are you working on? This is the 100 volt emote thrower solenoid circuit. I used opto isolators, but it seems like every time you use opto isolators, you open yourself up to the judgment of the internet, and they always judge you harshly, because technically I really should have a DC to DC converter on this, which would just take 5 volts in and turn it into 5 volts out, but it would be isolated through a transformer. It would turn it into AC and then back to DC. That's really the way you should do this, because that way your circuits are actually isolated instead of having a ground go from one side to the other. I mean, it's not like 10 volts, 100 volts is going to arc this far, but I did want to have some kind of isolation in there. So my positive line is an isolation, but all my grounds are coupled to one another, which is not good practice, but it's what is available to us with the stuff that I have kicking around the shop. So that's sort of the circuit as it is. We need to do a couple more of the lines right now, and we're kind of going through the voltages and the grounds and stuff, and just making sure that everybody has continuity. So this, which one is that? Hold on a minute. Did I do the wrong one? No, it's power shutdown ground, right? Yeah, power shutdown VIN. Or rather, VIN shutdown ground. So VIN has to go to this. That's going to be 12 volts. So that'll be a yellow wire that I'll put all the way back to here, which is the input of the 12 volt line. I guess I'll take it up to here. We'll do that right now. Let's get that one going, and then we'll check over our 5 volts. We still need to go back to the voltage regulator with it. I'm hopping around. We're hopping around with different various pieces of functionality that need to be achieved from this circuit. And eventually we'll run out of little tasks. And then we can hook it up to 12 volts and actually test it. I think I have to find a 12 volt regulator. Brick. The theme music for Lane is very, very good. I am falling. I guess I can go So it's, oh, wait, it's in, out, ground or something like that. This is an LM1117.5. We've got the data sheet open right now. I need to check my ins and outs on that thing. Or do I? OBS PowerShell? No, no, no. LM1117, pin out. Oh my God, home row error. That's actually a cipher. If you want to code all of your speech, you go off by one row of the keyboard. Ground out in. How do I have this thing wired up right now? I don't think this is connected yet. So in is all the way over here, which is actually quite convenient for us because our in also has to go all the way up here. So what I'll do is I will drop this. I'll drop this right here. It's actually really convenient for us. Our input is over there. I sort of assumed in ground out. Uh-oh, I think I may have this wired completely wrong. I'm going to have to check over my work in a minute. The voltage regulator might be wired completely wrong. I don't think it's that easy. Ugh, that moved the other one. That's all right. All right, we're just going to live with that. Pull that up a little bit and we'll come back to it. So it's ground out in. And actually, we just need to check over to make sure that this is exact. Because the LM1117, I've seen two different versions of how it's wired. So let's just double check and make sure that we've got exactly what we're looking for. On semiconductor 117-5. Let's get the exact one. 117-5. Well, pin out wiring diagram, that's all great, but data sheet. Now, this is on semi, but it's not the right thing. Ours is a 117-5. This one's all data sheet, so who the hell knows? Yeah, they're all going to be 1117, but this one is very specifically labeled 117-5. Right. Well, it also has a dot on that center pin, so let's see what we got over here. LM1117 on semi. I mean, okay, fine, I guess. Because we are SOT223, pins 1, 2, and 3. Adjust out in. So, okay, so our 5 volts is coming out of that center pin. Our input needs to be going to this pin over here. So I guess our input and our output caps are like across from one another. What have I already wired on this thing? Ooh, that looks confusing as hell. What is that? That's all this stuff. Ground, ground. One's going here, the other's going there, and then this goes this way, and then it goes across that. So this is wired backwards. One is ground, and I have it hooked up to this thing. Everything I built is wrong. Everything I built over here is wrong. So anyway, right now what we're doing is we're doing our 12 volts to the power supply. So we'll come in over here and go to that input pin right next to this. And I'll wire it up to that capacitor in a minute because I need to actually come in here and clean up everything that we did previously because I did it wrong. I assumed in ground out, which is typically how your voltage regulator works, but this one does not because it's stupid. We have it facing up, ground out, in. Weird. So I guess what I'll do is I'll move this up. We'll move the what you call it up, and we'll have power going up and over. No, wait, because the underside of this thing is exposed. There's like a thing that runs up the regulator. Oh, what have I done? Got myself into a situation. Let's undo all this stuff in the voltage area. By being hasty last stream, I made so much more work for myself by messing up. All this crap right here is wrong. It needs to go. Actually, what I'll do is I'll just clip the caps where they are, and we'll wire this up with my thinner wire. I don't think we're going to be pushing high current with anything here, except for the switching stuff. We can use my little noodly wires, and I think they'll be just fine. That is a banger theme song, though. I will give Serial Experiments Lane credit where it's due. The theme song slaps. Absolutely. Okay, let's get all the solder out of there because it's getting drippy. As drippy as Goku in his Supreme jacket. See how that one didn't even remove all of it? This is dripping. Does he drip? And this is a mess over here. What a mess. What a mess this is. Let's see. These are the pins. And then that's the heatsink over there, which is also the output. So you just suck the solder away from this. You know, sometimes I do stuff incorrectly, and mostly that's just to test you guys, to see if you guys are actually sharp. And so you guys didn't pass the test because you didn't notice this. And I kind of take that personally. I mean, it's your fault, but I take it, you know, as a slight on you. Okay, why is this getting all clogged? Big piece of solder. Yeah, I'm probably going to need to redo the tip of this thing soon. Okay, so this should be cut right there because that's a different capacitor. It's weird because I guess 12 volts is over here. I kind of want maybe this one to be 12 volts, but then that makes this one the 5 volt one. 5 volt one should go to the center pin because that one is ground. This is ground over here. And then my power's coming in here. My ground is over here. So this has to go to this pin. And then power coming in, that, I guess, maybe. But it also has to go through the MOV, the little regulator on the other side. So if I move this up, I could go up and over. I guess that's the best way to do it. I don't know if these are connected. I may have to put a piece of Kapton tape down here. Because if there's an exposed pad underneath the regulator, then it is going to foul up when it reaches, you know, if I do an exposed wire going over that. So maybe I'll do a jump of wire wrap wire, of yellow wire on that, and then I don't have to worry about any of that stuff. That'll be good. This one's ground. This one is the thingy-wingy. This one has to go. There we go. Nope, that's not. That's just shorting it out. Can I get this thing to drop down? No. Okay. Actually, wait. Yeah, I can. Wait. So if I do this a little bit, tickle it just right. I don't know if that worked. Almost. It twisted it a little bit. It is definitely not conducting right now because of how hot it got. But I'm going to move that up. Oh, that's not good for that. Okay, so get this over here. Get to that one pin. Oh, come on. Give it up. Give it up. Let's try adding a little solder to each end. I think I can get this off of here pretty easily. I got more of these if I ruin this one. I don't know if soldering, it should be able to sustain soldering heat without breaking. Everybody always asks about like temperature and time with soldering because everyone's always worried about it. I rarely ever worry about times and temperatures with solder. I don't know if it's maybe that things are just not as sensitive as they used to be, but I've never really had something permanently break because of the solder temperature that I've put on it. And you know, there are charts and stuff with usually with your, if your data sheet's worth anything, it'll have charts for time and temps during soldering in order to preserve the life of your electronics, because I'm sure statistically, as everything is statistic, we can get to this better from the other side. Statistically, I'm sure there's a chance that you can ruin your electronics by overheating them with solder, but I think it's pretty rare these days that things will permanently break just from your iron. And I guess if you're running an unregulated or like a crappily temperature controlled iron, you could run into that a little bit, but I generally just don't. I never have problems with this. Heat is heat. I think the braid might be necessary for this area. Yeah, let's get out the braid. A little bit of soldering braid goes a long way. This is just taking advantage of surface tension in order to attract solder. It's basically a wicking action that pulls the solder up and into the copper braid. It should have a little bit of flux on it. This is from product from Chemwick is who I use. There's lots of different manufacturers of solder braid, and you can get it cheaply and you can get it very expensively. Mine is somewhere in the middle. You find a brand that you know that works, and you stick with it, because you just never know. You never know, homie. Okay. So, ground. That's over here. So I can pretty much just go like that. Doot, doot. And in doing so, that'll keep me from going towards the edge of the board with that 12-volt line. So maybe I should go up and around and go to ground. And that way this can go across to that location. So I can have the protection thing over there, and then this pin is input. So I guess we're going to take this here, and then I'll do 12 volts as an exposed line underneath it. I don't like that, but it's not that big of a deal. So that'll just go to there. Oh my God, Willow, please stop barking. Oh no, I actually want it to be a solid line going down that way. What am I gonna do? I guess I'll put Captain tape over these three, and that way, or over the two, and that way we can isolate it out, and I can do an exposed wire going up and over to this, well, actually to these two. All right, so first things first, let's get this thing in place. So, well, actually, ground, yeah, let's do ground. Ground. Willow's just barking at the door. She's just having the time of her life, barking at anything that moves. I had a little scrap piece of the exposed wire wrap wire sitting on the desk, and I do not know where it went. I don't know where it went. You guys certainly can't see it because it's too small. I think it actually fell on the ground. I think I heard it fall on the ground. Oh boy, that's a Wait, that's the wrong wire. That's not it. Keep looking. Keep looking. There's no way I'm going to be able to see it. The vacuum will, of course, clean up after me later. Ooh, I got to move my legs a little bit. Everybody move your legs a little bit. Don't want to get blood clots. I'll just strip one of these down. Yeah, Willow's been... no, she's been totally fine. She's a perfectly great puppy dog. She's very cute, and she's very sweet to people. Wonderful dog. Does bark a lot, though. She's a corgi, after all. All right, so ground. Ground. This is a switch. I don't know where that switch connects to. I think when you plug the barrel in, this isolates, and then this is your ground always. So I guess what it does is it isolates from the power pin when something isn't plugged in. So I don't really want to do anything with the switch. I'm just going to leave it alone. It's just how you can have your barrel plug charge up your tape deck and then disconnect, and then everything else is connected. It's a way for you to sense what's plugged in physically, route things around. So we're going to go down there like that, and then we're going to put a nice little right angle bend in here. I'm just going to make sure that we're flat down on the PCB. Flat dune. I'm going to grab this sort of midway. Because these are rounded ends, it's going to bend in kind of a weird place. So I'm not very precisely grabbing it. I'm just kind of holding it in position. That's way too far. Hold on. Fine, I'll close them and just push against it like that. That way I can get a little bend in there. And then we're going not to the voltage regulator directly. We're not going directly to it. Oh, no, yeah, we are, because we're ground. This is ground, so we're going directly in. So we go directly into the ground pin, which is the first of the three here. So that way, I need to get this out of the way. Move out of the way. And then this gets a bend. We're getting there. We're getting there steadily. We got time, so we'll be able to get there on time without me dawdling too much. So that ground is going there. I'm going to have to then run it out to any other grounds that I want to... Oh, that's wrong. Actually, it's going to the wrong place. Son of a bitch. All right, so I'm actually going to go up one more hole. No, my bend, my beautiful bend. I pulled too hard. There we go. One of these. And so now, give it a little clippy-do right here. Man, I'm just thinking about what kind of overlays that I can do now. Because I could do all kinds of different effects. And using the, well, I don't know, using the Stream Deck or OBS can display like a web page. I could do all kinds of weird stuff. I probably should have dropped up to the top layer, but I'm going to keep it down here since it's ground. See if I can push down on that and keep it down there. Keep it down now. Nope. But yeah, I've already done the obvious ones, which is a light bulb that tells you what's going on and a something to throw emotes, but there could be many other interactive things in this system. I'll have to come up with them. I could have something talk your message. I don't know if I trust you guys with that one. That one seems like it's a little risky. All right, what I'm going to do is I'm going to check continuity on the underside, because I don't recall whether or not there is an exposed pad under the surface mount IC. And if there is, I've got to put Captain tape down. If there isn't, then we're good to just run straight over to our, whatever it is, current control thingy. So I've got to test from here to the underside to see if there's, these two holes are isolated. So that, I'm grabbing the multimeter, putting it down on the desk where you guys can see the output. Going to ohms. Ohms is the only mode that you should use. You should not use the beeper unless you can't see the screen. Because in ohms mode, it gives you more information about what you're poking at. If you've got a resistor between the two tabs, the other mode is not going to tell you what's going on. So I always use the ohms mode. I really don't like this area. I don't like what's going on here. I do not like it. I guess I don't have to, but it seems to me to be kind of bad. Oh, well, anyway. Okay, so over here, we have our output on these three vertical ones that are the heatsink, and then that has continuity, 0.3 ohms. This one has nothing. This one has nothing, sort of. Yeah. And this one, and this one. Okay, so they're not actually connected. Dig way deep down in here just to see. They're not connected. Okay, so we can actually connect 12 volts here by going up and over to where the little circuit protection Jiminy Jam is. Good. That gives us a nice little 12 volt area here. That little Jiminy Bojangles. Oh, and then I have to hook the caps up to everything too. Ugh. Work, work, work. Work, work. Nope, wrong place. We are here, and I'm going to put the little circuit protection guy. Yeah, way out here, maybe right there. I gotta find it. There it is. Hopefully it's in good shape. It's been put through the paces a little bit here. That's going right there. I'll just give it lots of solder to make it cooperate. The handle for the vise is getting in the way. All right, well, my iron's coming from this direction anyway, so Jesus Christ. I need to find an alternative for this vise. Jeez. Everything's just getting knocked around. Tweezers, there we go. Okay. This is in kind of a little bit of an angle. I want to make sure that my iron isn't contacting the vise because that'll push it out of the way. There's no excess of solder on either side. If the iron comes into contact with the vise, it'll start heating up the iron or whatever it is, steel, whatever they made this thing out of. Yeah, let me pick this up because I got to get real low to the PCB in this area. It sucks all the heat out of the iron, is what it does. So I add just a little bit right here. Right here. My iron's off. Oh no. Stupid multimeter. It has a giant neodymium magnet on the top of it, and so it attracts to anything metal on the desk. This thing is great for hanging it off of the desk, but when it comes up to the desk, it'll pick up all this crap. I'm going to put it over there again. Okay, it's got a little resting spot. All right, so you and you. It slides into place. Oh, I want to be a little bit further over. Did that not solder in? I think it was still molten. Yeah, it's still molten. There's so much heat in that area. Oh, that solder made it down to the thing. There we go. All right, there we go. So this will go straight over, and then this will come out to here. So that'll go over to here, and then I guess I can go into this capacitor, and then output here can go into this capacitor. So it's input cap, output cap, and this is ground actually. No, it has to go, this one has to go yoink to here. So it'll go to here, and then I'll do the cap over there, and then this one goes straight over. All right, underway as we go. Go watch the beginning of the stream, or at least the the end of the start soon part of the stream. Okay, so that's that. That goes straight down to there. So exposed wire. I'm just gonna strip one of these. Go. That goes to here. That's our 12-volt input through our protection circuit. I guess I could hook that up using the power supply for this time when we pull it through its paces. But in the future, I can actually find one of my little 12-volt bricks, the little barrel outputs. I'm going to run out of those. I'm going to run out of those just because I'm using them on everything. And now we can actually jump to here with exposed wire because we tested continuity on the device. It does not have exposed pads underneath. And this is our 5-volt output. So I can do this. Actually, I can start over here. What is this one? Oh, that's the pin I'm going to. Yeah, that's right. So this is the capacitor. And then this one's going to be our output capacitor over, or no. These are the grounds. Is there a cap there? Dun, dun, done. I think I messed up. Wait. Yeah, I think I messed up. The ground can't go there. Ground has to go out to here. So we need to rerun ground. Oh my goodness. It's all gone to shit. Because we can get to that cap here. That can go down to this cap. Ground will have to go out and around. Okay. We got a method here. It's just I gotta get back to do the corrections. There's a lot of heat. Once I get that rolled up, I can start removing it. I have lost it all. Help me to breathe. Where is the other lead? Yeah, it's right there. Okay, so yeah, that was the wrong lead. Peugeot 205 for a truck. I don't know. The Peugeot 205 I do not know of. I can't pull up a picture of that in my memory because I'm too American for it. I got cheeseburger in my blood. This is a very practiced maneuver. Resetting the solder sucker with one hand. You build muscles for it. Muscles. Okay, that one I can leave. All right, so this is in fact connected to 5-volt output, 12 volts here. So 12 volt here and then back over to this one. Doot. Unless I want 5 volts here and then 12 volts would have to go all the way around. So that's not going to happen. So yeah, unless ground goes up and over like that. But ground also has to be down here. So we might as well just do ground going out, down, and then this goes straight over. And then 12 volts are here, goes there. This one the output just goes here. And this one's gone all the way around and blocked everybody. I don't know. This is looks like an 80s Ford Fiesta. All right. I think I know of that. I think I do. Is that the one that Gonad had? I don't know. I wish we had more blockies 80s style cars around here. I found I probably already talked about this when you were in chat, but a Volvo Amazon. I would love to do like a big Volvo Amazon project, like make it electric. So you have something that is like really kind of 1960s Sweden, but it's actually a modern EV. That would tickle me pink. That'd be a great project. If I actually had like a normal person's budget, which I don't, because yeah, I don't have any money. So if I had a normal budget, I could get a Tesla, because they're all super undervalued, or will be anyway. I could get a Tesla and strip it to its bones and use as many of the bones as I can on the EV, and then give it its own brain. That's not a Tesla brain. That exists. Those are pretty cool. That should be ground for that part. Where else is there ground? Is U ground? U is ground. Okay, so I can take that. What are those though? I don't think that is a ground. Is that a ground? Big thonk. What are we on here? That is a ground, and I could actually remove that wire from it. Use, well, actually the wire needs to jump over what it's jumping over, isn't it? Wait, what's going on? Everything is a mess. The bottom one is ground. The one we're headed towards is a ground. Actually, this is totally fine to do. I can go right up to this. And then we got to sort out the rest of that area. And that should ground. Everybody should now be connected to ground if I connect that. Although I probably could have gone on the bottom of the board all the way up to here. And then that would have gotten us all the way over to there too. That's really sloppy looking. All right, anyway. I should have done this the way I normally do it, which is to run ground first, and then everybody else kind of deals with it. Everybody else deals with what ground has got going on. Okay. Oh, that's unfortunate. I'm not going to get that any further back. And that is where the capacitors are, right? Yes. Okay. All right. That could be seated a little further down. Those are a little too woobly for me. The caps get woobly. Bad things can happen. Basically, they can knock up against stuff and get woobled out of place. I wish I had space for cars. Okay, there's that line. That one, that sucks. I must have pulled on it when I was doing other stuff. Still, okay, so ground there goes to both caps and everybody else, and basically the whole rest of the circuit board. So we're just going to clamp it down to the board with a bunch of solder. Then we got to figure out the other signals, the power and the output. The output needs to go to 5 volts, all the 5 volt stuff. And that gets translated to 3v3, which is only going to be used to illuminate infrared LEDs inside of the optical isolators. That's all it's doing. This is a fairly simple circuit. It takes about 5 minutes to put something like this on solderless breadboard. On the soldered stuff, I guess I'm just a little bit out of practice. It's taken us a little longer to sort of commit to the board. And I could have done a couple things differently to kind of organize things better, but this is just the way that it's going down. I'm just doing this by the seat of my pants. And my pants are soaked. So let's do, so this is in, ground, out. No, it's in, out, ground. Ground is Which direction? Ground is which one? Ground is pin 1, which is to the right, so it's going to be to the left here. So this is input. So this would be 12 volts. Which means that, oh yeah, that's coming from there. Coming from this pin all the way down to here. And then 12 volts starts on these two. So we're going to take this and we're going to connect it straight over this way to this pin where we will have 12 volts sneaking around there. I swear with this vise, I don't have cuts in this thing, so when I press down on it, it just drops the PCB. And I usually have a larger PCB, and there's usually a lot more force on it, and I can't get a lot of force into it because it's got a knob instead of any kind of a handle. It is so frustrating. It's something that I need to fix. But if 12 volts comes down like this, then we can get 5 volts just out of this right here. 5 volts will be over here. All right. 2 to 4 cars are in the chopping block. I'm also moving some shelves from the garage into my machining cave. I'll put some wheels on my shop press, an engine crane. Oh, that's pretty nice. Now, printing an extra thing that'll rattle around is too obnoxious. What I'm going to do is just put it on the mill. I'll just put it on the milling machine and just get an end mill that's the right width so that I have about this distance, maybe a little less than this distance right here, on that as a little shoulder. But that requires a lot of aligning and stuff, so just haven't done it. I need to make sure that everything is like super duper perfect, or at least within as much as I can get it perfect. I need it to be perfect in order to do that. You know, I could also go, well, up and over or down and under. It doesn't matter. It doesn't matter what direction that goes in. Let's get a little bit of exposed wire here and come over to this side. And I'm going to do just a little, where are we? Where is my work area? Here we go. What are we doing? We're going over and up. This one's going over and down. So we can start here. Shouldn't there be solder on this one? Who should we raid today? Do we know? I really want to finish this thing today. I guess we can get it into test. Yeah, it's only, we got an hour and a half. I don't know how much I'm going to get done. With my artisanal hand-built circuits, there has to be a faster way. Well, yeah, if I used CAD and I just order a PCB, but getting all the parts into CAD is the hard part. You know, or I get a vinyl cutter and some copper sheets, I guess. I can design the circuit. Designing the circuit takes so long, though. Just getting out here and building it with your hands is the that's really the key. Leave your ego at the door. Iteration number 3. Julian's mixer is scaring me. Luckily, Julian is a little busy for the next couple weeks. And of course, he has always said, if it's not fun, don't work on it. But I still am obligated to get him a working mixer circuit because he's very excited about it. And I need to build it all on a prototyping board again, because I need to check the phases of audio as it goes through this thing. It's been sort of bothering me in the background. And then the keyboard project is also on its second iteration, which that needs so much. I need to do rule violators in the software so that the castellated pads can work. Got a lot going on. And yet here I am doing emotion stuff, emote stuff. Because it interests me right now. But I guess I get to set my own pace, except for you guys always reminding me of my shortcomings, which I really don't appreciate lately. But that's streaming for you. Leave your ego at the door. These are stuck together. I hate flux. This is why I don't like flux. It sticks my tweezers together, and then when I try to pick stuff up with my tweezers, they're stuck. And so it'll keep holding on. And you can't put stuff down. Why do I smell plastic? What did I do? Usually when I hit something that's flammable, usually when I hit something plastic, I'll smell plastic. Why am I smelling it now? Smelly smell. There we go. That's nice and clean. That's connected there. Now I can fill in some of the other areas. This is just basically stapling it to the board. It's just the way that I do this technique. I don't need to solder these in. It also reminds you that these are soldered when you look at it from the other side, so you don't accidentally run like an exposed wire over it, something of that nature. Sometimes these turn out brilliantly, but mostly they look like they are a complete mess, and for the most part they are. But this technique is okay at building sort of your semi-final version of your circuit. It has its ups, it has its downs. Not as sloppy as some ways of building it. I've even seen circuits where they've taken one of these copper sheets that you're supposed to etch away, and they've literally just carved it with like a knife, carved and scraped their way into having a PCB, which is a fascinating way to do it. It seems like there was a lot of hatred and anger involved in building the PCB. Where is my regulator? So this pin right here, which one is which? What's going on here? We haven't run ground yet. 5 volts out is coming from right here. So I can go to the top of the board if I really need to, or I can come in and sneak out from that capacitor. Where is our first node of 5 volts? It's right there. So that comes all the way back to here. So we might as well do a wire in that case. So I'm going to do a red wire. Red wire! I don't know why I said it like that. You got to do silly voices when you stream. It's the only way you can keep yourself entertained. And if I drop to here, I can go straight over to there. Although that's a little weird. So I could go up here. No, that's too high. All right, so all the way down here. Let's just drop this across. What is that? That is something. Better bad direction. Thanks for popping in and popping out. It's done. I really wish I had project car money these days. It would be fun for stream too. The problem with feeding it like this is that it runs into all the stuff that's under the PCB. So let's do a little bit of that. Let's get this thing. Kind of twist it from underneath. Get that soldered down. Hello? Oh, it's the tab, and the tab, yeah, the tab holds a lot of heat. So, all right, that's temporarily soldered. And then we have our pull-up over here. I guess I can just drop right next to it. Whoa! Burn me! Hey, Bother. Hey, Smith Clay. How's it going? How's it going? Can't burn you. Don't have the ability. I can go across ways, but that's just going to look bad. So if I go directly down, major deja vu. I just got huge deja vu for some reason. I don't know why. I feel like that's weird. That was very weird. Deja vu. I mean, there were instances where it was late in the day and I was building circuit boards and someone drops in while I'm figuring out sort of a weird portion of the power supply that I've done that I didn't like. That has happened before, but it just feels very strange and very familiar. Kind of bad practice here. I'd like to get rid of the stuff in there, but I don't think I can. But I will expose this for the whole run. Actually, I need to get a little lower. Don't cut it, 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 don't cut it. That didn't actually strip the wire though. Don't cut it, don't cut it, don't cut it. Ooh, I think I got it. And then if I can get this to strip away. Don't think I can. I don't think I can get in there and get that out. Maybe it'll boil away. Thanks for the input on trying to find an STM32 on short notice. Never did find one, but got it solved. Now to figure out where my Dymo 550 Turbo went. The labeler is such a good thing. Yeah, I don't, you know, STM32 is, for me, that's super duper easy to find, I guess. Maybe not an STM32. It depends on what Micro Center has. Whatever Micro Center has, I can get that in a jiff. I can just pop over there. But not everybody is near a Micro Center, much to my chagrin. And I think maybe you just live in the wrong place. You need to move somewhere where there's a Micro Center. Okay, power is connected to everybody supposedly, even though it's very sloppy. On near one, they just don't have STM32. What is powered by an STM32? What other things do you think? You could run to a music store and pick up a modular synthesizer module for $300 and get the STM32 out of it. There's got to be other, like, I mean, there are like start boards. There are boards where you learn how to use the thing. What the hell's all that? Unlabeled Deja. What? Deja, unlabeled the deja vu? What? Wait, what, huh? What's going on down here? This is 12 volts. This center one is 5 volts. That's running all the way up there. And this one is ground, and we haven't run ground yet. I've got ground running out to here. So now I just needed to go, oh, but wait, 5 volts connects. Yeah, so ground has got to go down and over. Weird. Okay, well, we're almost there. It's just going to get a little wacky. Things is going to get a little wacky. So I'm going to do a 5 volt line here. That's going to go down and over to the capacitor, where it'll back up all of the voltage supplying elements of this circuit board. We didn't get a boy dog, so I'm not able to do that's a good boy. I can't do that weird inflection in my voice. What a good boy. Say it like you're bouncing a spring. It's a good boy. 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 Bring. That would be the Mario 64 noise. Actually, that was in Mario World, I think. Yeah, that one was in Mario World. Not Land, which was the game that I would always beat Super Mario Land on the Game Boy. Game Boy. During car trips, 9-hour-long car trips. New Hampshire, where my old folks used to live. We are going to ground, so we're just going straight down like this. Bada bing. You have it. I probably could have done more of the circuit board like this, where I'm just kind of like routing stuff around each other. because that would have been a little bit more organized. This is why, so I haven't done one of these in a little while, and so this is getting myself back into stride, back used to these techniques that I use in order to build circuit boards, and most of it should be like this, where I'm doing closed circuits that are on sort of one layer of the circuit board, and then the other layer I reserve for wiring. And I use mostly surface mount because surface mount gets out of its own way. Unlike the through-hole stuff where you've got an entire thing on the other side of the board that you got to worry about. What the hell? What the? Try to crush that down so that it's against the board. Trying to kind of karate chop it on that one side. So that's ground connected there, and then I guess we do the through connection. All this stuff. Does look a little greasy. Put it on the method of taking a piece of cardboard and putting all the through-hole components through it. That is an incredible technique. It's very weird. It looks like total ass, but I guess it works. It gives you a PCB substrate. Well, not PCB, it's PCC, printed cardboard circuit. All right, so 5 volts in ground is connected to the rest of the circuit. The one thing that remains, if I'm correct about this, if there's not some jump in the circuit somewhere, is to connect the digital lines. So I am going to go to Arduino. ARD. What's that? No. All right, come on. Come on, Arduino. I know you're not doing anything complicated. You just start up very quickly. There it goes. A new version. No. I'll upgrade this at some point. I tried to upgrade a little while ago, and I would try to start Arduino, and just nothing would happen. It was like I got a virus. Open recent. Skeleton of the solenoid. We skeletonized our solenoid thrower so that I could use it on other stuff. So maybe I want the... No, I guess we just use this. Robot name is Punchbox, Glorious PCMR, Dead Beef, that's all my information. Charge time 500 milliseconds. D0 and D1, so the solenoid pin is D0. So D0 and D1. Und D1. D0 und D1. We're going to have to use D1 and D2. So D2 will be connected to D1 will be connected to the shutdown. So D2, D1. What? D2, D1. There we go. Okay. So that's the Control S that. That's going to be our setup. So now I need to run the pins back to the pins. So we have on the D1, this is the D1 Mini Pro based on the 8266. They basically took the chips out of the little can and put them down onto the board. They gave it a little protection. They gave it a little 3-volt regulator. There's, you know, a diode. They did their due diligence. This is a good little board. It's like $5, so it's way more expensive than just an 8266. So this is good for like development projects and throwing onto a PCB, but it's also old and sort of overshadowed by its both its predecessors and its the subsequent, you know, things. It's got a big old antenna chip in it to give it good good connection to Wi-Fi, but in the end, it's just not all that useful. So I'm using it here just because I can find it. It's just there. I always wondered if these are FCC certified without the can. Probably not. I wonder if they're using a little bit too much power. That might make it a good candidate for a project that I really want to do, solid electronics. I need to make something for it first. I need to actually build an Onagachi with its own battery. I need a decent sized battery on an Onagachi that I put in my pocket and walk around my neighborhood until I get the Wi-Fi credentials of every single house that goes around the circle and all of its subsequent sideway, like different ways and sides of the street and stuff like that. Because these houses are terrible for reception, but if I can get enough of a mesh network of Wi-Fi, I'm wondering if I could get one of those little Wi-Fi RC car things and hook it up and then put a big old battery in the 1/10 scale RC road car that I have. We'll probably have to print out a stupid body for it, but then hook it up to my steering wheel and my computer and have an actual like FPV driving rig that can go all the way around the half-mile circle here. That'll just have reception no matter what. I think that would be hilarious. The only problem is if I crash, I got to go outside. But I could be down here streaming it. That'd be so funny. I don't know if I'll be able to achieve that, though, because our Wi-Fi situation here is ass. All right, so to hook these up, I'm going to use, I guess, the white or blue. Let's use white wire for this one, for the 2 Ds. Yeah, I think that would just be a hilarious thing to do, but I don't know if I'll be able to really pull that off. So this should go here. This one is D1. That's coming out here and going up to here. Aesop rock song stuck in my head. Actually, wait, this one should be closer. The other one should be out there. So yeah, this one can come from here. You know, I'm doing it this way because if we need to expand, I will have space to do so. That's sort of part of the justification for why this thing is done this way. Should we go up above? Yeah, okay, so yeah, that'll go up above. This is just me reaching under it and finding where my stuff is and twisting the wire in order to spin this. But if I pull too hard, it'll shoot away. I'll just have to force it into compliance. You must comply! Herc! Yeah, it's gonna be a problem. Oh, there we go. Okay, like that. Jeez, this is sloppy. Yeah, I don't know. The houses in this neighborhood are pretty dense, so I think I'll be able to get a good coverage. But the only thing that would really hurt that is if, you know, just like I have trouble getting my own network outside of the house if there aren't enough coverage of networks outside. So maybe I need to do the walk around the neighborhood while looking at the Wi-Fi monitor on my phone and figure out if everybody's got a network in the area. But breaking into everybody's Wi-Fi is a goal in and of itself. Drop my cell phone service so that I just have Wi-Fi. Solder that down. Push it down. I'm not gonna have time to check over my circuit. We'll just have to plug it in immediately. I should have done all this stuff over the break, but you know, time being what it is. And let's get the blue wire in here while we're at it. So blue wire. Where's the end of the blue wire? What's going on here? There we go. A little bit of blue wire for my D2. This is D1. D2 is which way? Oh, it's labeled underneath. That's nice of them to do. D1, D2 is right below it. And so that'll go in front of it. So actually, that goes right. Oh, that should have been out one. Oh, well. Going right next to the header. I don't like that. But it's the mistake that I made. It's fine. I don't think I'll do anything with TX and RX anytime soon. We still need to program the GVM, the Good Video Maker light, with custom Tasmota, so it speaks that TX and RX packet to its own internal microcontroller, and I can send direct commands to it for color temperature and stuff. Because as it is right now, there's an ESP inside of it, but you have to give up your whole internet to that ESP in order to control the GVM light. So I just have it on one of my smart sockets. I also found out that the switches that I was buying, the little switch thingies that you can buy like a 4-pack for pretty cheap, they're not the monitoring kind. They're in fact a light version. And the light version doesn't have any of the telemetry of the Sonoff S31. Model S31, and then after it, look at this. This shit. S31 Lite. That means it doesn't do any of the telemetry stuff. I was so disappointed because like the places that I use these, it would be nice to be able to see how much current and stuff is being used. I've got 2 S31s that are running the Good Video Maker lights. Those are smart ones, so they'll tell you how much current they're using. What a bunch of piss. Like, man. All right, so the white wire is D1. That one is going to the solenoid, or sorry, the relay. Where is it? Wait a minute. What am I doing here? I mean, I can literally just wire these directly. Yeah, I should have gone wider with the second one. Okay, wait a minute. We can still correct that. I can still correct that. I can still correct that. Let's just get the white wire in there. Some kind of stone wall, any kind of odd force trying to make a phone call. What? Let it in, let it in. Okay, so blue needs to go out further. Out further, farther, further, farther. Let's grab this and just yank it out. Where is it? It's right here. Strip this long. Give it an angle. And then drop it in. To which one? Over by the micro. It's right here. Drop it like that. This is, so if I go to this and don't do it on the microscope, then I can align the wire properly. So, because it's like spinning around in there. It's hard for you guys to see at this distance. I could pull you guys in a little bit more claustrophobic, but what I'm going to do is just do this by hand and quickly, because I would like to get a test of this thing before the day is out. Or my day is done. And that's going to come up into here. Oh no, up into here. The close one. This one is a close talker. We can see whether or not this thing can actually get switched by 5 volts. This technique is a little bit neater if I don't have you guys to keep impressed. If I don't have to worry about like my camera work, it goes a little bit smoother. But okay, so these are just connecting to there and there. So all they do is, wait a minute. That one connects directly above it. And this one goes all the way over. This doesn't look like it's got two things on it. It should be going one pin over. I guess the solder didn't make it down in that one. So that one only goes over one pin. So before we forget and I mess up, I'm going to do that one because it only skips one. Now, hold on, I got to clamp this. Jeez. So that one goes to here. And then in pushing down on this board, I'm going to end up making it fall through. Let's just do this because it'll be less force. Hit that. Hit the other side. Again, I need like a little hook-shaped soldering iron tip or a pair of tweezers with a nichrome wire that heats up. And I could just pluck. That'd be great. A great little tool. I could probably make that into some kind of like a handheld battery-operated tool. I gotta think about doing that. Some stream. It would be, I don't know if you could get away with a 3D printed handle. I think I need to buy like a pair of tweezers that were a weird shape, that were like stainless or something like that, so it doesn't transmit all the heat. Or I could modify some of the ceramic tweezers, but it needs to have just the right light touch that I've got on this. And I didn't like the ceramic tweezers that Wexo sent in. I didn't really like. Still have them. That's that one, and then this one goes directly over, so we can just drop the hammer on this. Might be a little too short. Let's hope it still works. Cannot force trying to make a phone call. Nah, let it in, let it in. Bring around the revenue. Let it in. Ouch, I just poked my finger with that. I'm going to pull this out a little bit. Don't cut it, don't cut it, don't cut it. All right, let's get that all soldered. The wire bouncing around is one of the disadvantages of this technique, is that the wires kind of want to spring back to where they were before. Right, that one's connected. This one should be connected. Skibbity, skibbity connected. Get rid of this over here. Outcropping. All right, so now, all things considered, everybody should be hooked up. We've got a ground on each side, basically the schematic that I showed. We have our 3-volt lines that are connected only to the opto isolators through a 1 kilo ohm resistor. We've got our power supply over here that's being given 12 volts for the input. 12 volts is going through a regulator. The 5 and 12 volts both have a big capacitor on it just for the sake of keeping it clean. I think we're ready to go. This is not a complicated circuit. There's just a lot of weird stuff that I need to hook up. And I probably could have done this a little bit differently if I organized it better. Instead, I'm just kind of jumping from thing to thing to thing. But we've got 5 volts going in here, which is going like that and going like that. And then 5 volts is, what is it doing over there? Hold on. 5 volts. Oh, we're skipping over to there and we're going to the top of both of those, okay? Because one of them, this one holds this at ground, and when it's activated, it goes up to 5 volts. This one holds it at 5 volts, and when it's activated, it goes to ground. So circuit's pretty clear. As long as I'm not touching this thing, I should be pretty safe when I boot this all up and try it in just a second. Let's just clear this stuff away just in case I have a fire. You never think you're going to be the one who has the fire in their shop, but you know, it may happen one day. I'm going to have to get the fire extinguisher and totally ruin probably the entire rest of my evening. by releasing a bunch of fire extinguisher crap all over my stuff. It can happen, and it can happen to you. And it'll happen when you least expect it because you're relaxed and you're complacent, and all of a sudden everything goes really wrong. Heed my warning. Jeez, that's a fart box right there will be fine. You not have halon? Why would I have halon in a closed room? What are you talking about? Let me get my CO2 extinguisher and just let loose in this little room that I'm in. Isn't halon the one that kills people? I don't know. I have just one of those home fire extinguishers that are just sitting over there. Like, I mean, I know I'm on Tech Twitch, but I'm not like a professional building. Like, this is a room in a house. I guess I'll get standoffs for it later. I'll just plug in, put it on the vise. I'll put it on the vise because that'll hold stuff steady. And then I need a plug to plug into this thing, which I know that I've got something down here that's got leads coming off of it. Is this thing the right size? Convenient, although I don't know if it's going to make great connection. I'll have to find a regulator or a, what do you call it, a power supply at some point. But we can put this over to leads. I'm pretty sure that the stripe is going to be the middle. I guess I'll have to double check it. Do check it, and then we'll turn this on and it'll fizzle out because of some stupid error that I made. Because you guys saw the errors that I made originally. You know, I had to redo the whole power supply section because the pinout was wrong. So if I power this up and it fizzles out, that'll be our rage quit moment. Yeah, that's connected. Okay, and double check this one to ground. Well, and then to 12 volts over here. Okay, so that should be good. Uh-oh, free up storage space. That means that my recording drive needs, it's gonna overrun, and my recording is gonna stop. If this recording stops, just know that everything happened perfectly and it worked amazingly the first time we tried it. My first assignment in US Air Force was at Vandenberg, the test facilities. The underground place at Halon System installed red police type lights on the walls and the signage that said you have 30 seconds to leave before stuff floods the whole. Oh my God, that's rough. That's like, we gotta go. 30 seconds or you're dead. That's insane. Yeah, but like, was there an elevator to get down there? I guess I gotta get to the stairwell in 30 seconds. All right, we are going to observe this thing charging up. Oh, these I can't plug these into the wrong places. If I do, that means that the thin wires are being used to discharge capacitors. That would be a bad thing. These wires are already a little bit too thin. I'm actually kind of wary of them. Worked in biochem, same shit. That's crazy. Yeah, no, we don't run that stuff in my house. I don't know what people expect from Twitch streamers, but certainly not Halon systems. So 12 volts going in and then 100 volts setting off the solenoid over there. So you'll be able to see this thing kick. That'll probably fall over when it kicks the first time, but whatever. Okay, so turn on the power supply. It takes a minute to turn on. I got to do this before my storage space is used up. Let me start the transfer while we wait for this thing to power up. the little bench supply. Oh, and then I have to program the Arduino, so let's do that before we do any of this other stuff. Let's bring this up, and I can actually program it remotely. I'm going to do it with, yeah, I might as well just do it remotely. So let's wait a second for this. We'll do this over the air. So I need to just do my due diligence here and grab the recording drive and just grab everything but today. Today is the 8th. So we'll take all these, cut them, and we put them in to storage 5. And eventually that'll transfer over. Okay, so now that the power supply is on, we're not giving it 12 volts yet. So this is where we really have to pay attention to the circuit. If I were responsible, 8, 9, 10, 11, 12, if I were responsible, I would slowly bring this up to power just to make sure that everything's right. And nope, I am just literally going to hit this thing with 12 volts right now. 3, 2, 1, go. Did anything happen? 11.98, 0.01 amp. No activity from the Arduino. You know, I think there would be a blinking light on this thing somewhere. I didn't really add lights to this whole thing. We also don't have the 100 volt circuit hooked up yet. So I'm just going to make sure that I'm getting power into this properly. Let's check to see if the Arduino has 5 volts on its input. You guys want to know how this stuff is really done so that you don't get flashy explosions? This is how it's really done. You go piece by piece and make sure that your thing functions properly. The barrel connector's in, it's just very long. The 0.1 amp is not enough amp, so 5 volts and ground. Oh, milliohm, whoops, volts. Not even a volt. So something may be shorted out. How about between here and ground here? Okay, so we have 12 volts on the very input. On the other side of the cutoff, we also have 12 volts. So that means that over here, we should have 12 volts. We do have 12 volts, which means here we should have 5 volts. We do have 5 volts. But then from, okay, let's switch hands. From ground here to 5 volts here, we have 5 volts. Okay, so we actually have 5 volts going in, and we have 3 volts coming out. 4 volts coming out. Well, that's almost 5 volts. What a 3 volt regulator. What are you doing over here, man? What's going on? Wait a minute. Yeah, these are the high voltage probes, and they give you this really spiky front. That's actually kind of vital because you can poke through oxidation on lines. So, okay, so what I want to do now is see if I can, maybe I didn't program anything for the built-in LED. Setup pins, built-in LED, pin mode, LED built-in output, low. And then when we get to the end of setup, we do setup done. Oh, yeah. So I blink the LED when we're done setting up. I must not have noticed it then. So what I can do is go into the tools, and I can choose the port. It only sees Fartbox 3000. It should see Punchbox, which is what this is. Let me restart the micro and see if it doesn't appear to do its little flashy bit though. Okay, let's see. mean, we're getting 5 volts from that input, but then we're also getting 5 volts almost at the 3v3 output, which is not really making any sense to me. I don't think we burned the microcontroller. Why would I then not be seeing that? Because that's, I can trace out the 5 volts from this pad here. It goes up and around and down, goes into, or actually no, it goes around and into the diode, and then it goes into the circuit protection thing, and then that goes down to this big old plane where it goes to 5 volts over here. And then also that hits the voltage regulator. Rigel bench DMM. Is there voltage on the board at the 3v3 pin with the ESP port out? I don't think there should be, but we can check. Take this thing out. Oot. Take it out. I'm a Canadian. A boot. Ha ha ha. Peak comedy. That's not really how they sound, but okay. Negative 9 volts. What? Huh? Well, huh? Negative 9 volts. What are you talking? Oh, no, power's on. What's going on here? Half a volt. What? 0 of a volt. What? 5 volts? Oh, we might have just killed this thing. If 5 volts is able to get into that way, but that's up here. That's isolated. Why would that be doing? No, that's not getting over there. Ooh, maybe it was. Even still, this should be ground. Negative 1.6. Are you high? Okay, so from ground to power, that's fine. And from power to ground, that's not fine. That should be getting 5 volts. Ugh, I got some checking over to do on this circuit. Hey, wonky robot. Why then would from ground here to this pin, oh, now we don't have 5 volts. Maybe something was just hanging out on the line. Still got weird voltages running around. Strange. Negative 4.9. So, let's see. This should be ground, unless it's not connected. This should be 5. This one might not be connected properly. That's what I'm thinking, is something went horizontal and vertical, or sorry, X and Y, and they ran over one another. Potential between these two. And of course, I'm not doing anything with this entire row, so there's nothing happening there. But this would be the 5 volt and ground right here. So really, between these two pins, I should be seeing 5 volts. I'm not seeing anything. Before I was seeing 5 volts, it's a little weird. Is that somehow a cold solder joint? I don't think that could be any more definitive of a solder joint. That is definitely soldered, although not incredibly well. Let me just unplug the power quickly. Everything is rearranging in weird ways. I may have to fix this tomorrow on my own. Open ground, maybe? Well, this doesn't look incredibly connected. We'll just make sure that the solder is good on that. Let's trace you back to ground. up, over, and around, and that gets to this pin here, which may, that goes over this way. This is why I should have done this all on one side. All of these ground connections should probably have been done all on one side, and then I could check them over much more easily. Ground is going up and around. I mean, you can just see it on this side too. And then like that. And then black wire comes in over there. That gets us up here. That grounds this, which also grounds the 100-volt supply. And then that goes to this cluster, and you can see a wire coming out that way. So out that way it goes. It goes to the 2 caps, and then it comes over here where it goes to the, what are those things? The positive ones up here, negative down and around. This goes up and over where it gets to the pin of the regulator. Yeah, that's right. And skips over. This is the 12-volt line. Or sorry, the 5 and 12 volts is happening just fine. It's just the question of what's happening to it when it gets out there. What just happened? Wonky Robot! Papa did up here at the dark side to say yay. How's it going? Thank you so much. Thank you for the sub. I don't see many problems with my grounding here. This looks fine. My ground or my power, even though it's a little bit crazy, and I probably should have stuck to one layer and one technique. I should have run all the grounds first on the underside of the board, and then everything else is secondary to that. You run the ground, run the power, then do all the signal wires. But as far as it goes, I'm seeing 5 volts. I see 5 volts on the output of the regulator. It's not being overcurrented at all. I don't know why it wouldn't. Let's check again now that I've reflowed the solder. So if I plug it in like this, 12 volts says nothing is really happening with it. And then if I bring my probes up here, and I probe this thing here and here. What? What? What in the world? That don't make no sense. Wait, is it actually these two? No, even less so. It's definitely the 2 on the end, huh? Yeah, ground and 5 volts should be these two. I'm getting negative 5 volts. Hold on a second. So 5 volts up to here, where it goes under stuff. So if I go from ground here, let's do continuity now. So 5 volts is coming out here. We'll go to ohms. So we shouldn't really see ohms to here. Son of a bitch. Wait, how is this? What? Huh? 5 volt is perfect continuity out to here. How about to here? It's doing great. It's doing great. We're really proud of you. Yeah, that's doing fine. Okay. What about to, because I'm going from this tab here to this. You're doing great. We're still proud. The ground. It's all over the place because there's capacitors. So now let's take ground, which is this pin here. And we go to this. Doing great. To this. Naha. This. 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 Okay. Up here. That is connected. Why is it not connected down here? What is going on? This and this should be connected through that wire under the board. Oh. It just stops. Okay. All right. All right. So, all right. It's unique. So let's just get a wire for that. I already put away all the wires. Yeah, it was just open ground. No wonder I got such weird readings. Troubleshooting. So if you guys didn't catch on what was going on there, that was an expert tutorial in troubleshooting. I did that to test you, and none of you passed because none of you saw this problem that I caused myself to have. That's the whole purpose of this stream. I never make mistakes. I'm just testing you guys. You've all failed. You've all failed. All of you. No, even you. So iron's off. Turn the iron on. Nice floating. You shut the hell up. Tell me when I'm floating. Okay, so now I am coming from that ground, just here, this big old cluster F. And so I guess what I can do is just jump up. I mean, I could also go back behind it in order to get up to there, but I think it's just better if I, well, you know, nothing's really going on back there. And this is all clustered up. No, but really all I need to do is just connect this to this. So let's just figure that out. This is just going to drop down with the wire. So I will do a black wire for ground. Black wire for ground. Let's bring you guys back so you can at least see my hands doing stuff. He's doing stuff. Have to earth both sides of the zero. Yep. You gotta have those earthy grounds. Very heady, earthy grounds. So I really don't want to block stuff when I do this, but I guess what I'll do is I'll just go from here and the wire will go under everything. So I'll just bend this to the side and then drop it through. We are close. We're close. We're close to being able to put new program into this thing, which will redefine where the digital pins are. Then I'll be able to test it, and I'll be able to bring it up to 100 volts. You don't connect the 100-volt supply first. You just don't do that. So while I apologize that there aren't screaming and explosions, there isn't screaming and explosions. You know, there's a way to do stuff and a way to get injured. I don't want to do either of those. This is unfortunately going to cover over another thing that I've soldered down, so I don't really like that, but we just got to live with it. That's just the nature of the beast. Well, I could go back and up. I could go here and then up. I'll do that just for fun. Test with 210 first. Yoink. A little sloppy. It's a little sloppy. I really should have stuck to my guns and done all the grounding first on one layer and then work around that in order to build the rest of the circuit. And also move those opto isolators to a slightly better spot. You know, all that stuff that I forgot to do because I just jumped into this without thinking. Ever mess with the Arduino opto PLCs? No. I've heard of the Arduino PLC. It's kind of crazy that they would put Arduinos into industrial situations, but it is a easy to program, easy to learn, easy to work with microcontroller. So I guess it's pretty good. But I don't know, programmable logic eludes me. I probably would have been big into PLCs and industrial controllers if I had stayed in the sort of major that I studied. I'm not going to do a PCB for this. No, there's no point. It's a bunch of modules on a one-off circuit. There's no need to do. This is as permanent as you know something like this can get. Obviously, a PCB would be a little safer, but we're not all about safe here. We're just a little bit about safe. That looks really weird. What's going on with that? Okay, I think it's fine. All right, so now, all things considered, I should be able to plug this thing in and get it to power up without having weird voltages everywhere. And we should see a red light flash on this thing when I power it up. This isn't the nervous power up. This is the one that we know will work fine because there's no 100 volts on it. So if I hit power over here, 3, 2, 1. Oh wait, no, I plug it in. 3, 2. Oh, let's focus in on this. 3, 2, 1. Are you going to blink? Did not blink, but it's also not getting hot. And I'm doing 90 milliamps right now. So with 90 milliamps, does that mean that I still don't have the port available? Any of y'all getting warm? This thing's getting warm. Are we actually putting out the 5 volts properly? 90 milliamps is a healthy amount of current. It's not too much, it's not too little. But what I should get is ground here and output here. Oh, it's off. You didn't get me nervous. You didn't. I jumped a little bit at that, actually, to be honest. These guys try to scare me with the stupid what? Who said idea? This here. Remember, you guys got a delay. 1 volt. All right. This thing has 12. Still 1 volt. Hold on, let's dig in a little bit. One volt. So the power thing is heating up. Too many milliamps for it. Let's turn off the power, let it cool down. See how quickly it gets overheated. Why would that be overheating like that? I don't think there's a short between power and ground. Let's do a quick ohms test on power and ground. Between power and ground. Negative 46 kilo ohms. The moving power means that the capacitors are doing stuff. 5 volts and ground. Moving value. 5 volts and 12 volts. Moving value. Maybe this is under spec. It's like, okay, let's see. Right now it is. Was that OL low or high? OL is low and it's 6 ohms. So it's 6 ohms on that thing. And if I plug it in, what happens? We run 110 milliamps. And is this heating up? Yeah. So it's going to run 110 milliamps until, yeah, now it's at 80 milliamps. So it heats up way too quickly. This thing is well below specifications. I'm going to take it out of the circuit and we'll just short it for now. Because I don't think there's any reason that it should. I probably should have used one of the other ones that were higher current than this. I think this might be like, well, it should be like 500 milliamps. Maybe I got the 300 milliamp one. For now, we're just going to short it out, and I'll find the other ones later. Come on, get out of my circuit. You fired. You're going to be replaced with a fusible link. You're gone. Goodbye. Oh, that's ruined. Took the pads off. All right, so now we just need a tiny little wire over that end. Let's see here. You know, I did everything right. Put all the right safety stuff in. See, now the solder won't flow up into the wire. It just flows down with gravity. With gravity. That was good. Okay, hold on. Get solder. Blood pressure rising. This wire is prone to cold welds where it doesn't flow onto the wire, and it gets very frustrating because of that. Pre-tinning helps. Can't always pre-tin though. I'm pre-tinning to the choir. Ah. All right, that should be pretty good. We don't need a fuse on the circuit. This is such a low current circuit for most of it. That thing, if it was a 1 amp poly fuse, it would have been a much better choice. But I don't think it was 1 amp. I think it must have been 250 milliamps or something. Because this will probably draw a little bit of current for a brief amount of time when it's functioning. So, all right, we got everything hooked up again. We'll go to this arm view, focus it so that if anything explodes, we can see it explode. And then I'm going to hook it up to power again, but we still don't have the 100 volts connected. It's still lower voltage. We just need to watch out on this end over here to make sure that our thing doesn't, blow up. Let that cool off a little bit. All right, ready? There's our LED, and we're 200 milliamps. That LED seems a little bit bright. I guess the initial inrush was enough to piss it off. Oh, and it turned it off again. So it did all of its initializing. Or, uh-oh, or it blew up. That's not good. Oh, now it's 0. Uh-oh. Now it's not drawing any electricity. Oh no. I might have blown up my Arduino. How? How would I have blown it up? It's impossible. It's impossible. Now it's drawing 0.2. The volts. I'm not getting any voltage. How's that even possible? What the hell? What is going on here? Something is cursed. I'm getting 0.2, 0.7, 0.6. Ground. 12 volts. That's at -12. This one is 5. So that one's at 5. Something isn't connected between these, but we ohmed it out. We ohmed it out. It should be connected to here. Yeah, I'm not getting anything. What the heck? But why is this on? What's going on? .1 millivolt. 0.1 millivolt. All right, so turn the power supply off and let's check. Oh, is that making a good connection? That might not be. Well, why my LED is turning on? Is it in the port thing? Port. No, it's not showing up. All right, so bring this thing out again. Check 5 volts. And we're doing ohms. So 5 volts to this pin. 0.3 ohms. Five volts looks like it's going to ground. I think that's just parallax. 5 volts is all the way at the end of the header. And you can see the wire underneath the board going into that header. And you can see that it has ohms. So is that not connected? I think it is now. Let's just check. Ground. Here. Ground. What? 0.3 ohms. You're not correct. You're not correct. You're wrong. 5 volts right there. There it is. You can see the wire under the board. Check continuity again. From here to here. Ohms. And then from here to here. Not getting ground continuity. Again. Oh, that's probably what's going on then. Yep, it's ground continuity again. So if this isn't connected up here, now, see, you guys were wrong. It was this that was causing the problem. That incorrect. I mean, if I was off by 1, that was the lesser of my problems. Well, I don't think you guys have it correct, but if you're convinced, then I will believe you. But I think it was this joint right here not being finished. And why it would give partial continuity until something bad happened. Now it is definitely soldered. Yeah, take a screenshot. I'll take a look. Okay, so then now that I power it up, it'll probably all work. So let's give it, let's see, I powered it off over there. I'll power it on, then plug it in. So powered on, let's go back to this view so we can see everything. And now we should definitively get our power and ground to this thing, and I can have all these things out remotely where they won't shock me. And that is 160 milliamps. And we're getting pretty big heat coming out of this little voltage regulator on the ESP, even though that's not really doing anything but powering up itself. But that might mean that we're functioning properly, as long as these things don't start smoking. 150, 200, it's almost at 300 milliamps. Oh boy, it's jumping up to 1 amp. Whoa, what's going on? Something's burning out. That is 300 milliamps for one device. That's kind of, I don't think I have it wired weirdly. Why are you drawing so much current? 300 milliamps now. Well, that's not hot. No, that's not hot at all. It's just the ESP is being a little dramatic bitch. It's the actually the thermals are being dramatic, because if there's a tiny bit of heat, the thermals auto range themselves. Like here's 98 degrees, and so the whole board looks a lot less warm all of a sudden. This thing is still kind of, ooh, ow, yeah, that thing's hot. That one is definitely hot. I need to add like a big piece of wire to it to dissipate that heat. But that should mean that this thing is, it's not on the network. Why is it not on the network? Through in Discord? Let's take a look. Let's see how I'm wrong. I'm wrong. Yeah, I'm wrong. Sure. That was off by 1. It's funny that I didn't see that. And that doesn't look like parallax. You found a pretty good shot where it's pretty straight up and down. So it was off by 1 hole. Live and learn. Well, anyway, that was also not soldered in. But like this almost drew an amp for a brief amount of time. Let me try resetting this. Hit the reset button and see if it'll try to come back to life. We're not really doing anything crazy with this. I just hope we're not sinking too much current through. Yeah, it's only getting a little bit warm. D1 and D2 I don't think would tank the device. And I really should be seeing it in the port. Well, let's see if we, I might have buggered the whole circuit by putting voltages into the wrong spots. I think being indexed down 1 was okay. I I don't think it's fatal for the device, but it might have been. No, that would have killed this. It would have killed stuff upstream. Because if I'm throwing 5 volts into ground, it's not doing anything to this. It's doing stuff to this part of the circuit. Really, all this is doing right now is putting current through like a 10K. Let's see if this thing still works if I plug USB into it. Oh, look at all the heat. How much current does this thing draw? Look at that. It's a monster. ESP's heating right up. Let's just check our pins. There's COM7 and there's Punchbox. So they're both starting up perfectly fine when it's plugged into USB. Let's upload our code just to make sure that we've got the right declarations of pins going on. So I'm just going to upload it from here. That's crazy. We didn't break the board. Luckily, we sort of jumped on the grenade and simply, by being indexed off by 1, it would have been sending 5 volts into the ground pin of the ESP, but there was nothing to reference to. So when we got it plugged in properly, sending 5 volts into that pin, unfortunately, there's no protection for that 5 volts coming in. But if we plug this thing in properly, it should be okay. Wait, did that just transfer everything and suddenly I've got a ton of storage space? That's nice. I didn't know that was still doing in the background. Or is this Arduino being weird? Might be Arduino being weird. It has a lot to compile. I think my file transfer is done. That's nice. Now I got space on the computer. I don't have to worry about it. I still got an ad on me. Somebody has an ad on me way over there. Okay, come on, Arduino. Don't have all day. We already had all day and we used it. I already used all of my day. What is this alert? We published advertiser-friendly guidelines. This is so stupid. Gift sub savings have dropped. Get 35% off bundles of 5 or more until 3/31, 10 a.m. Pacific time. Terms apply. Now you guys got slightly cheaper subs on your end. What? Device not ready. Reset. Oh, that could mean that it's broken. Maybe we can do it through, we might have killed the USB, the power supply maybe, but the punch box says it's there. So what if we program it over the air? Let's say it's not ready. I might have broken the USB functionality of this thing. When you got potentials running into pins that aren't supposed to be there, it can cause weird stuff to happen to a microcontroller. We can always throw this up onto a different Wemos. I could use one of the ones with ESP. Error, no answer. Uh-oh. We might have killed the ESP. This one might be dead in a weird way. Funny though that the COM port shows up, like everything shows up the way that it should, but when we go to program it, everything goes to hell. And this thing is hot. Okay, I think we're dead. I think we're DOA. So I've got other ones. The reason I use this is because it was dregs. USB is fused right on the board? What do you mean? Yeah. These are like plug and play. These are very easy to use. D1 Mini Lite. You're the next one on the chopping block. So we got to choose the right Wemos. So tools, Lolin. I wonder if Lolin is a subset of Lolman. ESP, Lolin, Wemos D1 Mini Lite. This one has less memory, but our program's not that complicated. Now that it's MQTT, it's like super light. We can put it on whatever. So I'm going to mark this one as dead. This one has some nice parts on it, so I'm going to keep this board. But put a big old X on it. 2 X's. Now let's plug this one into USB before we introduce it to the horrors of the board that we've created. Let that come up. This one has a PCB antenna on it. COM5. And then upload. I think we'll have plenty of memory. That's cute. They're about the size of the little emotes that Wexo printed out. It's about the same size. Look at that. It's like you could hide one inside the other. I could put one on the back of one of these and be wearing a little backpack. A little all backpack. It's like just the right size where you could mill out the inside and put the circuit board in there. Cool. Since this one's the light, it's got to recompile everything too, so it's going to take a little bit longer. I think I have another Pro, but I don't think we need the Pro in this application. So I think you were, as Smith Clay, I think you were right on every front. We broke it by putting 5 volts in the ground, and I plugged it in wrong. And I killed the Wemos D1 Mini Pro. But I have replacements, and so here we are writing in to the light our whole program. Clip it and send it to my wife so she knows every now and then I'm correct. Finally, some vindication. Spring arm. Unplug the voltage. I'm a little concerned for our 5-volt regulator. It seems like it should be good up to an amp, and we're not really using an amp, but sometimes things got a little hinky on this. So we plug this thing back in, and I plug power back in, and we see if we blow it up again. If we blow it up again, it probably means that something weird is going on with the circuit for the actual pins. The circuit for the pins is literally just an LED circuit. That's the beauty of these, what do you call them? Opto-isolators, is that they are literally just an LED on one side, right? You put the thing into the LED circuit, and you figure out what your resistor is going to be. So I could have probably done something horribly wrong with this part of the circuit, and somehow 5 volts is getting all the way into the ESP. I hope not. I could do a quick continuity check to make sure. Let's do that before I power it up. Continuity check is your best friend when it comes to these kinds of things. Because when you build these crazy like soldered circuits, all kinds of like weird little errors can work their way in. Whether it's an error of parallax and you're not looking at the pin you thought you were, or if it's just a simple solder bridge error, they can be devastating and quite common. That pin is 3 pins down, TXRX D1, D2. The D2 goes out to all my peoples. D2 goes to the shutdown pin. Let's just double check that. Enable pin is D2. Okay, good. Good. So then D1, wait, that's D2. This one goes out to shutdown, right? This one to shutdown. No. This one goes to shutdown. Oh, wait a minute. D1 goes to shutdown. D1, this one, 1K. Yep. And so D2 goes to the trigger, the FET. 4, and then on this side, we get 1K. Okay, so we got to swap them. There we go. And then off of the board, I'll program it just to be nice. and then we will see if our voltage regulator takes a shit when we give it power. The light is a better application for this. These MQTT things are not that hard to get code running on. It's like 100 lines of code. How many lines of code is it? Okay, 200 lines of code. It's not a lot. All right, COM5, let's give it the new program. It's like 200 lines of code, and all it does is monitor MQTT. It's a perfect application for an ESP8266, or in this case, the Wemos that I bought many, many years ago, and I've never found a really good job for. Use my hands to talk. You know, you gotta have some kind of animation going on. My audio seems a little weird today. Is it okay? Am I consistently a good volume? I think I am. Hard resetting via RTS pin. We have the port listed as another IP address. It's 2.160. I'll have to restart Arduino in order to get rid of that. Audio's good? Okay, good, good, good. So now, unpluggy the thing. Pluggy it back into this without getting it off a row. Okay. Now, all things have been tested. We get our continuity. Oh, I didn't actually know. One thing has not been tested. From the 5 volts output to D1 and D2. Okay, that's as good as it gets. Double check. Over here. Both sides of the resistor. Just to make sure that we're not discharging through a 1K resistor. So, all that stuff considered, this should be good to go. We've got our positives and negatives on the lines of this stuff. There shouldn't be that much leakage. If I plug this into 12 volts, we're drawing 0, even though the regulator probably gets a little warm. So if I plug this in, and I don't plug it in badly, plug that in just as is, just like so. We can get the multimeter out of here in case crazy stuff happens, but I don't think crazy stuff will happen. I think this is one of the instances where we were cautious enough that, and I, you know, as much as I love to throw caution to the wind, I make a lot of mistakes when I build stuff. I'm not that good at it, right? So as much as I love to throw caution to the wind, I'm not that good at building things, and so to make up for it, we know troubleshooting really, really well. So power on. That LED flickered. We are drawing 80 milliamps, which is a nice little sum of current. Our Arduino, our ESP8266 equivalent, D1 Mini Pro Lite is getting warm, but not hot. The LED is constant on. That's concerning. That might be a power LED, and the other ones, no, I don't think so. So let's check to see the port, tools port. I see 2 punch boxes, but I don't know if they work or not. I could test it here. I could hook up the multimeter and test voltage on the pin, and I could trigger the thing. Or we can now take this and we can plug the 100 volt power supply into it and see if it works. Oh, here we go. Here we are at the end of things. My whole life flashing before my eyes. That connects to ground over here and goes to the regular ground. This one can go to the other side, but it also connects somewhere around there. Or is that one the supplier of ground? I think that is sole supplier of ground to the kicking circuit. Okay, oh boy, here we go. This one plugs in a little weird. Okay, yeah, that's good. Okay, we're all plugged in and ready to go. I don't want to do this. The LED built-in isn't used for TXR RX at all. I had an ESP32 variant. I have an LED blink program to keep the LED on permanently because of the TXR RX issue before. No, well, I'm not totally sure about the D1 Mini, but it should have the built-in LED connected to its own pin. Yeah, see, it's connected to its own pin. I don't know where else that's going though. If that goes to TX and RX, maybe it does. I don't really know. I don't really know. That's a totally unique and new issue to me that I've never heard of. All right, here we go. 100 volts. Ready? Okay. So there should be nothing happening. That's all correct. Once this thing gets up on the network, if it's able to, I don't see any power coming out of the power supply. It's not drawing any current. Huh. Could the PSU be causing something to not happen? I don't think so. And this thing supposedly went up on the network. Oh, is this just unreliable? Cable to cable. No current draw. I think this thing is a little less reliable. That's well soldered. I saw the LED flash a little bit there, so maybe this is not the best plug. It just did a little dance. Okay, 90 milliamps, 1.3 amps is being drawn. I'm gonna back away from this thing a little bit. I'm gonna back away just a bit. And I'm gonna go ahead with that LED on. I'm gonna go ahead and I'm gonna put an aw. I didn't see any voltage charge. I didn't see anything charge up. Did you guys see it? The needle didn't move. Did I get it upside down? Yeah, if that went further into the paint, that means that that's backwards. So that needs to be corrected. So power off. Give it a little bit of time to dissipate because there's big capacitors connected to everybody. In fact, pull the big caps. Ah, son of a bitch. So after one fire of the thing, I think it melted my crimps. That or my crimps just weren't good enough to be pulled on like that. Dang it. All right, let's get the caps out of here. I got to recrimp these like right now. We got to get this. We got to get this. I think we succeeded, but my crimps failed. Poor little puppy. She's going to be so disappointed in me that I went late today. Poor little Willow. So this done. This is what I was doing over the break, is getting all these crimps done so that we could jump into the circuit and get it working, which we did, but now I'm back to doing this because I pulled on the thing wrong. I need to set up a thing that holds the crimp so I can do this quickly. That'll do for now. It's not, what I like to see is a little bit of the silicon jacket on the other side of the crimp so that it's really holding it on. This one just goes in and just goes a slight distance. Oh, I think I sunk that one too far. Let's see if I can get it to work. Too far into the crimp. Yeah, I think I messed that one up. These I'm going to have to pull out and reverse. Too far. Damn it. Gotta get another one. Gotta get another one. I got plenty of them in here. Plenty. For crimps, they sell these really expensive crimping guns that do like all of the thing for you. That's why they're in these sort of like indexed holders, but those cost like hundreds of dollars. So I just use a generic crimper. and one tick to widen it out, and this into there. It starts to fight you. Push past just a little bit. Yeah, that's pretty good. Okay, so then the header was over here, and the order is blue, then green. So I wanted to oh, they're still in there. Need a knife for this, because you need to poke that little pin all the way down. And then you can kind of wiggle this thing free. One. The other one. And then we go blue on this side. And then green on this side. We make sure that they click in, because these haven't clicked in yet. So it's hard to push it with the wire, because the wire is super flexible. Yeah, there we go. Okay. So that's the solenoid. That can stay plugged in. It's the capacitors that I wanted to isolate. And then we do the same thing to these two, and I flip them into the other way. So ground first and then power. So I'm going to push down with the very tip of this knife all the way up front. And that will push down the crimp socket to the point where I can just pull it right out. And then I come into the crimp socket, and if you look here, hold on. We've done this so much on air that my tutorial has gotten better and better. I need to work the knife blade just under that little tab so that it pops it up a little bit. But not by much, just a little tiny bit. This one is ground, then power. Power is the one all the way on the tip. So when this is plugged in, ground first. Ground first, then power. Und then power. Okay, so this one here, flip that around. The cables kind of take the same path. And then work it in. There we go. Nope, all the way. The wire's not strong enough to push with, so I gotta tap it with a knife. Yoink, yoink. Good to go. That should solve all of our problems. We'll never have another problem again until the connector melts. That's why I built the system this way, so that we could do stuff like that without me risking my bacon. I like my bacon. Okay, all this out of the way. Slight correction. Now for the full test. 3, 2, 1. Get this out of the way. This out of the way. Hold on. Full test of the system. Everybody's raring to go. Solenoid, capacitor bank, voltmeter, ESP8266, opto isolators, TIP122, Nixie power supply, 5-volt regulator that's on fire. 3, 2, 1, and let me get my hand out of the way. Go. We're drawing 0.12. The LED did look like it did a little flishy flashy kind of stuff, which is not what I expected out of what I programmed. 2 amps. What the? 2 amps at 12 volts. What's happening here? We are at 20 volts from the Nixie power supply. I'm going to back away a little bit because 20 volts seems a bit extreme. When we had shutdown operating before, it was not at 20 volts. It was at 5. So there's something wrong. Let's just, I don't know, put an awe mode into the chat. Why did it go down? I don't think that adjusted at all. How's the high voltage power supply doing? There's a little bit of heat on some of it. Maybe there's an error in that part of the circuit. Why would it be being held at 20 volts constantly? It like drops down and then triggers. So I got to check out some of this part of the circuit. I think things aren't quite happening the way they should happen on the high voltage power supply. Yeesh. Oh, and my chat stopped scrolling. Why did it stop scrolling? I don't know. At least it's coming in up there. I'll have to check that this thing is hooked up properly too, because it might actually be at the right voltages. Maybe I just forgot to plug in part of it, but it really should be 0, charge up to 100, bang, and then that's the end of it. So we didn't kill any part of our circuit, well, more, and it appears the D1 Mini Pro is dead, but the Mini Lite is good enough to do this job. I mean, it's doing it right now. It's just I don't see any shutdowning happening over here. Now we assert a value on the pins, right? Yeah. Solenoid pin, low. Enable pin. Oh, wait a minute. Our logic is the other way around. Low. Oop. Our logic is different for the enable pin. So everywhere I do the enable pin output, we set it low. Then we, what is this one? Yeah, set it to high, end charging, solenoid pin high, and then we lower them both at the same time. Okay, so that should fix it. Punch box at 160. That should upload to this guy. I don't know if we'll see this doing anything. Let's see, still compiling. Compile. It takes quite a bit of time for these little guys. Uploading. It doesn't flash when uploading. Okay, so now, technically, if I give it an awe, it may charge the rest of the way. I don't have bleed resistors on this. It'll charge the rest of the way, set off the solenoid, and then go back down to 0. Or it's not connected yet. I guess it's still uploading. Done uploading. Are we connected yet? Send another one. Why did it spiked down? I don't really feel safer on this thing at 10 volts. Maybe my logic on the... Oh no, that went up briefly. Okay, so the remaining mystery is why is it at 20 volts and not much more? Well, the advantage of this system is that I can keep it live and move it around on the desk, with you guys able to activate it if you feel like. We are charging, see, that's at 10 volts right now, much to the chagrin of most of the system. Whereas these are getting warm. So I don't know if something isn't connected to this meter, because we saw this spike all the way up. And if those capacitors are getting warm, like what's going on, right? Why are my caps getting warm? Could they be backwards? Turn it off before they blow up. Oh my God. No more. Turn the system off. I don't want to mess with that. That's possible. It's very possible that the capacitors were actually plugged in backwards for some reason, even though I checked 500 times. That could very well be the case. I mean, this is why I have high voltage probes on the multimeter, right? If they're heating up like that, the last time I saw a cap heat up like that, it was bad news bears. This thing can take 300 volts, 600 volts. So we're in good shape. I can actually probe the caps and see what kind of latent energy is sitting on them without risking my life. This is very much the reason why Well, no, it's not the reason why, but it's one of the advantages of having these high voltage probes. So I'm going to daintily grip this from all the way back here and do just a little touch off. I shouldn't be doing this with my right and left hand. You're right. You're very correct. I'm going to do this with one hand. -1 volt. Wait, -1 volt. Yeah, these were connected backwards. If that's at -1.2 volts, these were connected backwards because I've got positive on positive and negative on negative. Son of a bitch. All right, I got to check over my work on Wednesday. That's what I'll end up doing. What could 1 volt possibly do? Nothing, actually. That's your answer. That's why they weren't charging all the way and why they got warm. We are very, very lucky that we did not get blowed up. Yeah, these are warm. These are like marshmallows. They're warm marshmallows. That could have been a big explosion. If they got hot. I don't think this thing has the capability of putting enough current into these to get them hot. So warm is not the end of the world. It's just these are supposed to have current running in one direction and not the other. Jeez. That was a close call, chat. That wasn't good. How did I do that? How did I cock that one up? Well, these are mysteries that I will solve for myself. So today we did the remaining of the soldering in order to get power into the rest of the circuit. We corrected about 16 different mistakes. I plugged in the Arduino wrong and blew up the D1 Mini Pro. The D1 Mini Lite was good enough to hold code and it was forgiving enough for us to fix the rest of the couple of issues that were with the circuit. Then we discovered that the voltmeter was backwards, which it probably wasn't. It's just the connection to the capacitors was backwards, and so I was charging the wrong thing. That's very, very bad, and I checked over my work many, many times. Luckily, we got out of it without any bulging capacitors. These got warm, but not hot. If these got hot, they could have popped off. It would have been a bad situation. So nobody is popping off today. We just have a couple warm capacitors. In operation, they won't get warm at all. Maybe. Hopefully not. But I'm going to have to let everything cool down, double, triple, quadruple check my work because that's a big mistake. I should not have had that happen. Thank you guys for the help in keeping me from not fucking blowing everything up. We're getting there. I think maybe by the next stream, I'll have this thing all situated. We can work on something else instead. But here's the end card because I'm done. I almost blew up everything. That would have been an earth-shattering explosion because these are big capacitors. I would have had ringing ears and maybe a viral clip. But I don't want to go viral like that. That's not me. That's not me. You guys can check me out on Discord. It's where I constantly am. It's where SmithClay corrected me, but was totally correct. And it is, of course, where I do all the administrative stuff for the channel as well, and where announcements are. Blue Sky, I also have that. I've found it to be pretty pleasant because all of the makers and stuff kind of moved over to it at once, and I was able to get in one of those group sign-up kind of things, and it brought quite a few users to my feed. I am not big on social media, so I barely ever post. You'll get some posts with Willow, and maybe every now and then an update to a project, but yeah, that's basically it. That's been me. Thank you guys for joining me. I'm going to check to see who else is on and not drag this out. Yeah, that's the new emote. Everybody's been using that look up emote lately. Gonad is on, but he has 25 viewers, and we rated him last time. So we're not going to rate him again. Let's see if anyone else possibly is on. Oops, hold on. Close this, open this, close this, open the other thing, close the other thing. Too many tabs. Show more. I do not see anybody. Okay, so we're going to close up shop. I'm just going to stop the stream, and then I'll be back on Thursday. And on Thursday, we're either going to, finish this thing up. Well, we're probably going to work on the mechanicals for this. I want to get it to the point where it can actually throw an emote with the 100 volts, and we can do a stress test and see how hot it gets. It's one of those things. I may also need to add like another on-off mechanism to this whole thing so that it really truly turns off when it's turned off. Ay, ay, ay. So yeah, we will rejoin everything then, and I will catch you later. Have fun, etc. Oh, I was supposed to drop it over to the channel in order to do the funny kind of joke where I mid-sentence